Hello, can you hear me?
Yes, sir. Yes, sir. Audible.
Yeah, yeah. Did you ask me to permit to start the program? I didn't hear what you said. Please
Sir,
go ahead.
okay, thank you, sir. I request all the participants kindly join your hands and close your eyes for the Punjab University Dhuni. Thank you so much. A very good morning to all of you. On the behalf of Punjab University Patiala, I, Dr. Richa Sharma, Assistant Professor in the Department of Electronics and Communication Engineering, Punjab University Patiala, extremely privileged to welcome you all in this online AICT Training and Learning Academy sponsored faculty development program on Internet of Things, to be held from 8th November 2021 to 12th November 2021. I'm happy to announce that this is our first AICT Training and Learning Academy sponsored faculty development program in the Punjab University Patiala. The theme of Internet of Things is the most demanding these days. We have around 160 registered participants from all over the India. For this, I want to thank to all the enthusiastic participants. Dear participants, I want to thank you, and you will deserve a huge round of applause. For making this FDP successful, we have a great intellectual team of resource persons from different IITs and renowned industries, as well as from industries from India, and some resource persons are from abroad. I extend a very cheerful welcome to our chief guest, Professor Arvind, our Vice Chancellor, Punjab University, Patiala, and Dr. Balveer Singh Sandhu, Dean Academic Affairs, Punjab University, Patiala, Dr. Manjeet Singh Patar, Associate Dean Research and Dean Faculty of Engineering, Punjab University, Patiala. Internet of Things comprises things that have unique identities and are connected to the internet. The focus on IoT is the configuration, control, and networking via the Internet of devices or things that are traditionally not associated with the internet. For example, pump, utility meter, car engines, etc. IoT is a new revolution in the capabilities of the endpoints that are connected to the internet. The great details are being discussed by our resource persons. Here I have given you a very brief introduction about the IoT. Now I would like to introduce my Department of Electronics and Communication Engineering. It was established in 2003 as the name University College of Engineering. It reconstructed as an independent department of university as in 2013 as Department of Electronics and Communication Engineering. Founder head was Dr. Manjit Singh Patar. It was followed by Dr. Gurmeet Kaur and Dr.
ஆன்லைனா
Ranjit
வச்சிருக்கணும்
Singh
போல இருக்கு.
Hamra and currently headed by Dr. Ranjit Kaur. We are having 4 professors, 1 associate professor and 21 assistant professors and 7 contractual assistant professors. Our faculty
ఎగ్జామ్
is
ఉన్నాయి
having
చూడండి.
PhD. More than 18 faculty members are
పెడతాను అసలు దాన్ని.
PhD. 50 plus registered candidates are in PhD. We are having the Visveshwarya scheme. More than 100 SCI scopus published at high H index. Our department has more than 10 books and ebooks. We are having the MOUs with IIT, Slide, and many other industries. We are having 3 DST sponsored projects and few are in pipeline. We are having the 4 international patents in the department. Now I would like to call Dr. Ranjit Kaur to give the formal welcome to the dignitaries and the participants. Dr. Ranjit
Very
Kaur.
good morning. Yes, am I audible?
Yes, ma'am, you are audible.
A very good morning to all of you. First of all, it's a privilege that we have among us our Honorable Vice Chancellor, Professor Arvindji. On behalf of EC Department, I welcome you, sir, and I thank you, sir, for sparing your valuable time. Your presence is always a source of inspiration for all of us. So I also welcome our Dean Academic. So he is not able to join due to some networking issues. Professor Balbir Singh Sandhuji, Dean, Faculty of Engineering, Professor Manjeet Singh Patarji, and all the other guests, honored guests, and the session experts. I think so in the morning session, Dr. Pushpindra P. Singh from IIT Ropar. So I welcome you, sir. And I also welcome our Professor Manjeet Singh Hamra, Professor Gurmeet Kaur, and all the faculty member of EC department and all the participants across the country. I welcome you all in this FDP on Internet of Things. So that is AICT sponsored. So as Dr. Richa has already explained about the Internet of Things, we all are aware what is the Internet of Things. So basically, this is the global networking of machines and devices through which they can share their information and data. So when we talk about the anything smart, smartphone, smart city, smart building, smart vehicle, then the term Internet of Things comes. So this Internet of Things help us to work smarter and to live smarter. So I also congratulate to Dr. Richa and Dr. Sonia for organizing this FDP, and I hope that we will know why Internet of Things is important in our daily life with the help of this FDP. So I again welcome you, all of you, and I thank you for your participation in this FDP. Thank you very much.
Thank you, ma'am. Now, I request Professor Arvind, Vice Chancellor, Punjab University, Patiala, for the formal inauguration of the ATAL-sponsored Faculty Development Program on Internet of Things. Sir, I am honoring you with this bouquet. Kindly accept our wishes.
Well, thank you very much for the bouquet.
Sir, over to you, sir.
Yeah. So I'm very happy that this program is being organized under the national program of AICTE. It's good to connect with national programs. It's good for the university and also good for the community. The topic of this particular FDP is very interesting and very topical, the Internet of Things. And one aspect of Internet of Things which is extremely important is the interfacing, because things that we want to appear on the internet have to talk to internet, and therefore we have to develop interfaces. So the program, I hope, will move in a direction where the involved faculty will not only learn about the importance and things about Internet of Things, but also should be able to get some basic idea how to put things on the internet. So my thing will be, since these are very practical subjects and we have so many engineering students, at the end of the FTP should be taken more in the workshop mode, where people at the end are able to at least interface one new thing and put it on the internet. And that is the process which has to be followed to bring things, connectivity of the things with directly with the net. So this is in some sense fascinating, because once you put something on the internet, it is first of all identifiable on the internet. Then of course you have to come up with parameters which that particular object or device or thing or person, whatever it may be, will actually communicate, what parameters will be transmitted to the internet. So this is where things are going, and there is no end to it, and a lot of imagination can be used to put more and more things on the internet. So I would like to see very soon our EC department putting things in the university on the intranet to begin with. Internet may be too much, but we can have all kinds of devices and things monitored through internet on campus. So if they're able to do such a thing on campus, then I would say that the FTP on Internet of Things was successful. I have seen the lineup of resource persons from various institutions, and I'm very happy to see the large number of participants in this program. And I wish that this program will be a big success, and the department and the university will move forward in doing more things in this direction. Thank you very much.
Thank you, sir. Thank you for your motivation words. Now I welcome and invite our today's resource person, Dr. Pushpinder P. Singh, Project Director, Technology Innovation Hub and Associate Dean R&D IIT Ropar. He is going to deliver his talk on cyber physical systems in the domain of agriculture and water. Now I request, first sir, I am offering you the bouquet. Kindly accept our bouquet.
Thank you, Richa for this.
Thank you so much, sir. Kindly switch on your video, sir.
Richa give me 2 minutes. I'm connecting with my desktop,
Okay.
so it can be better. Yeah.
Okay, sir. Okay, sir.
Thanks.
Now I request Mr. Lakshmi Shankar to share the biography of resource person for the participants.
Yes, good morning, all of you. Am I audible?
Yes, sir, you are audible.
So I'm going to share the profile of Dr. Pushpender P. Singh from IIT Ropar. So Dr. Pushpender P. Singh is currently Project Director, Technology Innovation Hub and Associate Dean IIT Ropar. Dr. Singh is a PhD in experimental nuclear physics from the Aligarh Muslim University and the Inter-University Accelerator Center, New Delhi. He received Professor CBK Baba Best Thesis Award 2008 from the Indian Physics Association. He has been awarded INFN International Fellowship at the Laboratory Nazionale di Ligarno, Italy in 2009, after a postdoctoral stay at the Tata Institute of Fundamental Research, Mumbai. During his stay at LNL, he worked on sub-barrier fusion and multi-nucleon transfer reactions using an electrostatic separator and prisma spectrometer in the research group of Professor Dr. Alberto M. Stefanini. After a term at Ligano in 2011, he joined the GSI Helmholtz Center for Heavy Ion Research, GmbH, Darmstadt, Germany, as visiting scientist, and the Nuclear for Heavy Ion Research, GmbH, Darmstadt, Germany. Spectroscopy group led by the Professor Dr. Jürgen Gerl at GSI. He has been associated with the Lund-Yoke Cologne calorimeter and the lower end electronics of advanced gamma tracking array. He joined the Department of Physics at the Indian Institute of Technology, Ropar in 2013. Presently, he is a member of New Star Collaboration for the Facility for Anti-Proton and Ion Research, FAIR, at Darmstadt in Germany, and collaborates with the scientists from JINR, Dubna, Russia, TU Darmstadt, Germany, ANL, USA, LASTI, University of Hyogo, Japan, Akshay University, Turkey, IUAC, New Delhi, TIFR, Mumbai, and AMU, Aligarh. He has been the principal investigator of a number of scientific projects approved by the national and international funding agencies. And he is the author of more than 60 research papers published in high-ranking international journals. Other information about Dr. Pushpinder P. Singh, Professor, he earned Professor CBK Baba Best Thesis Award in 2008 from Indian Physics Association for the best PhD thesis presentation in nuclear physics. And he is a life member of Indian Physics Association. So this is all about the profile of Dr. Pushpinder P. Singh. Now, may I request Dr. Pushpinder P. Singh, please continue with his talk, today's talk. You are welcome, sir.
So we
Hello,
will
can you?
start the talk at 10. First, kindly give some motivational words, and after that we are having 1-2 speakers, and after that we will start the talk. Kindly say few words about the FDP.
So, Richa ji, who's supposed to talk about it? Me or somebody else?
Sir, you, sir.
Okay. So, first of all, thank you very much for having me at Punjabi University. And it was a privilege to see Professor Arvind today after many years. I think last time I met him was in IISER Mohali. During Hoxilla, it has been organized at IISER Mohali for science communication and science and technology communication. And it was a joint program between, I think, German embassy and India. So it's actually a great privilege for me to see him after many years, I would say. Now coming to this particular program, first of all, I thank for very extended introduction to our colleague from Punjabi University. I think I don't know if I deserve such an introduction, and he read many things which was written on my profile here and there. Okay, so now presently I work particularly in cyber physical systems for agriculture and water. And this has started happening with me, though I have training in experimental nuclear physics. And when we talk about experimental nuclear physics, we actually talk a lot about instrumentation. So a lot of it is computer science and electrical engineering. And this is how it slowly, moved me towards cyber physical systems. Presently, we are running a project on cyber physical system at IIT Ropar, which is a national project under what we call National Mission on Interdisciplinary Cyber Physical Systems. Now, as Richaji said, that some motivational word. I don't know if I can actually motivate any one of you, because all of you are exactly in the same boat as I. We are none of us is in some way students, and in many ways students. But what I would like to say, when I will be talking about cyber physical systems today, you will realize that this particular domain has really a lot to offer, particularly in Indian scenario. So far, we have been talking about information technology. We have been talking about computer science. Now, this is the time when we should start talking about cyber physical systems and IoTs. So when we talk about cyber physical systems, this is just an extension of Internet of Things in collaborative manner. So many people are also saying that cyber physical system is nothing but the collaborative systems which are connected with internet and are able to take decisions independently, remotely, and accurately. So this is something which is going to change the very landscape of our daily life. And it has actually changed in many ways. For example, right now we are talking to each other and we are using some kind of cyber physical systems to communicate to each other. And I'm able to communicate to you through the very same cyber physical system. So we will learn a lot of things and in this program of a few days. But what I would like to actually submit to all of you is the following. When I will be talking for this hour, please interrupt in between, and we can talk. We can make it more like a dialogue than a talk, because all of us have been, doing this online interaction since last almost 2 years, and it feels really bad that one person is talking and then everybody else is listening. This is also happening in our classes. So today we will try to make it more like an interactive session, and you can interrupt me in between, and if I like, I may also ask you something, or maybe you can simply say something, whatever you like. So if you are okay, I can switch to my slides.
Okay, sir.
Or this is, or this is really, we are in time today, yeah? So. Richaji, I cannot hear you. Maybe your mic is.
Yes, sir. Am I audible?
Yeah, very much.
We are having actually two speakers with us, and after that we will start.
Okay, sure.
Now I request Dr. Manjeet Singh Patar to share some motivational words with us. Patar sir, can you hear me?
Good morning.
Sir, kindly accept the bouquet from our side.
Thank you. Thank you.
Sir,
That was
kindly.
a surprise for me.
Yes, sir. Sir, kindly
It's a
share.
surprise. It was not in the schedule.
Sir, actually,
okay. Good morning, everybody. And my best wishes for the participants. And I hope that they will learn something new from here, and that will help them in their future endeavors. And I also congratulate the organizers who have worked very hardly. And this program has now started, and I hope that it will went smoothly and it will be a success. Thank you, everybody.
Thank you so much, sir. So these are the beautiful flowers for our respected members and the participants who joined this inaugural session. Now I request Dr. Manjeet Singh Bhamra to give the vote of thanks. So after that, we will start the session. Dr. Manjeet Singh Bhamra.
So it's a very tedious equation for me. Good morning to all, because I am in traffic and it is a great block here. But anyway, let me continue. So first of all, it was a great opportunity that we are starting with the first time this program with AICT ATAL Academy. And since we got this approval from the AICT 3 years back, it is our first venture with the AICT. So for this, I really congratulate our faculty members who took the initiative, Dr. Richa and Dr. Sonia, of course, our head, Dr. Ranjit Kaur. It will be starting a path-breaking initiative, and I hope that our new courses, which are really in demand, and we want refreshing in our department, those topics, and we will continue such kind of the topics in the coming FDPs. And in this line, I am having a great hope that we will get a lot of benefit from these kind of the FDPs. And the second thing is the inauguration session. I have seen the words and listened the words of our Honorable Vice Chancellor, Sir, Professor Arvind. So the beautiful words they given us the idea that what could be the output of this FDP, that we should start interfacing the new devices on the internet. Then only we could say that it is the real benefit of the IoTs. So from that point of view, I am hopeful that we will start working on this part, and our whole of the faculty will do projects and initiate some tasks related to the IoT. I'm really thankful for our Honorable Vice Chancellor, sir, Honorable our Dean, who had consented but could not join with us. And secondly, the participants, particularly Pushpinder Singh ji from IIT Ropar, and the other other experts which are coming to give the services to our participants. I'm really thankful for all of them. And our Dean Engineering, Professor Manjeet Singh, rightly said that it's a start of the things, and start of the new things, and the experts all over the India we could find with the help of this AICT initiative. And although we were doing many FDPs from NITR in association with the NITR also, but the AICT initiatives, they will be totally different, because they will be technically in you say more focused to the technical points. With these things, I'm welcoming as well as giving you say a great hope to the participants that we will do a very good series of the talks, and we will learn many things out of this program. Thank you all of and the organizers, and best of luck to all of the participants as well as the organizers. Thank you.
Thank you so much, sir. Now I request Mr. Pushpinder P. Singh, kindly continue your talk, and you can share your screen. I'm making you the presenter. Yes, sir.
Can you see my screen
Yes,
and
sir.
hear me?
Yes, sir. It's visible and you are audible, sir.
Okay, okay. Thank you. Thank you very much. So first of all, again, thank you and everybody from Punjabi University. And more than that, I thank all the colleagues who are attending this FTP program. Why this is important, let's say, to thank and genuinely feel obliged to all the colleagues who are attending this program is because without them, this program doesn't make any sense. And I will be, for example, bugging them for almost 2 hours today, but we'll try to make it more entertaining and informative than boring. This is one thing. The other thing is that they can, in fact, interrupt, because all of us are exactly same. So there's no difference between all of us. Now, what I supposed to talk when I was discussing with Richaji, in fact, she said that I should talk about IoTs. So I thought of talking about IoTs, but then I redesigned my discussion into the domain of agriculture and water. Now, why I thought that this is important, point number one, that we are running a mega project on the domain of agriculture and water. And more than that, this is something that is very, very important for all of us, starting from this morning to the night, and for the future generation, and for everybody, because we all can survive without anything, but we cannot survive without agriculture and water. So when we talk about technology, any new kind of technology or new technology intervention, we should always think where this technology is actually going. And when we think about where the technology is going, we should put it on the priority list. And today, agriculture and water are actually on the priority list. So in the discussion, I will be talking how and where we can implement, deploy the IoT systems in the domain of agriculture and water. I'm speaking here on behalf of IIT Ropar Technology and Innovation Foundation. In this presentation, I will be going through 2-3 aspects, or in this discussion, I will be going through 2-3 aspects. The aspect number one is I will be discussing about a national mission which has been launched by Government of India recently to deploy and to advance the research base in the country on cyber physical systems, that essentially mean on IoT systems. And then we are doing a project at IIT Ropar. I would also like to discuss a few aspects of that project, and then we can go ahead and discuss what are the issues in the domain of agriculture and water and how we can address those issues for the better, practices in the domain, right? So with this, I think, let me first discuss with you what is the connection of IoTs with National Mission on Interdisciplinary Cyber Physical Systems. So we all know today that the information flow much faster than ever. Like I was talking to you in the introductory session when Richaji asked me to talk about kind of motivation. This is where I also mentioned this, that we are able to communicate today. I'm talking to you sitting here quite far from you because of the information flow. So because of the technology that is available for the transfer of information. We have seen a lot of technological interventions even during the COVID time. And one of the technology intervention was Arogya Setu. So all of us, even when you today go to the supermarket, the security personnel at the gate of supermarket will ask you, do you have the Arogya Setu on your mobile phone? Now what this Arogya Setu has been doing? Arogya Setu has been taking your data, taking your information, and letting you get information on if there are people around you who are suffering with COVID or have taken the wellness test, or they can understand how many people are there in the 500 meter of radius who are affected by COVID. So all of this was able to, do using a very simple application which uses the Bluetooth and the network of your device. We all have seen Google Classroom because being in the profession of teaching, we have seen how Google Classroom has transformed the very idea of teaching and learning. We have seen during the COVID time that we were able to communicate with our students and the colleagues, research groups using Google Classrooms and Meet. One of the example of IoTs and cyber physical systems is the FASTag. We use FASTag quite every day for passing on a road. We are able to pay immediately the moment we pass through a barrier. Online sell and purchase is not something that we doesn't know in our everyday life. It became a part of our life since the internet came in our life. So, but these days online sell and purchase become very, very extensive. One of the things that is coming up in the society, what we call Society 5.0, is the medical consulting. Today, when you go, for medical consulting, you go to the doctor, you pay 500 rupees or 1,000 rupees as a consulting fee. You meet the doctor in the real. And then sometime many people say that, oh, it's a good idea to take a second advice. Sometimes the sickness is complex and you always prefer to take the second advice. But then if you talk about the second advice, you have to again travel to the doctor. And suppose the doctor, who is a very good doctor, is sitting in Delhi or in Kolkata or in Mumbai, you have to travel such a distance. So the medical consulting is coming up as a big way in our life because it makes the life easy. You can submit and share your medical reports. Doctor can suggest what to do in this scenario. So all what I'm trying to say is that all the examples that I was trying to give you, starting from Arogya Setu to Google Classroom, FASTag, sales purchase, to the medical consulting, etc., all of it has IoT and cyber physical system in the background. Not to mention the automation in our houses. So even you can think of automation, and many people today, the lights, the air conditioners, the dishwashers, and water purifiers, all of them are connected with the internet. And you can switch them off, switch on, control their parameters, control the systems, even not being there physically. So all of these things are coming in a big way because of the fact that the information flow today is very fast. And the information flow, not only fast, but it's accurate. Okay? And this can be done in the real time. Now, if you look at, this is what we have seen. One example that I mentioned, forgot to mention, was also when you go to the market today. And I'm supremely impressed when you look at even a sabjiwala, and you buy vegetable from him or her, and you can pay 20 rupees, 30 rupees, 50 rupees directly to his account using your mobile phone. And you hear a voice that 20 rupees are paid. Think about this small device that is sitting with, in many cases, it is given by a company, OEM in India, which is in the, and I was surprised when I that how much money you have actually paid for this particular device. They told me that this device is though property of the company which has provided us, but they have given us only in 150 rupees. Now think about the hassle if you pay directly to the person, and think about the medical problems if you pay directly to the person in hand. Many of us do not realize that the number of harmful bacteria that sit on the currency note and on our keyboard are much larger than the toilet seat itself. So if you do run a test, on a currency note for the pathogens and on your keyboard, it will come out to be much larger than the toilet seat or the public toilet. So what you are doing when you are transferring money directly to the vendor through the IoTs or cyber physical system, you're actually saving yourself and him or her from transferring the disease. So this is something which is going to be extremely important, is important today. And then the other hassles like going to the bank, taking out money, doing everything, this is also saved. And this is just an example. This is one of the examples of the many technology intervention that we have seen in our lives these days, even in our country. But if you look at the developed countries, people and things are much more connected. The cars are connected, bikes are connected, shops are connected, trends and everything is so beautifully connected that you can get information in the real time. You can park the car using the sensory network that is sitting on the car itself. The car can park itself automatically and autonomously. It can realize what kind of obstacles are there when the car goes in the back gear and find the parking space. It can take decisions. So the prediction is that by 2030, that essentially means that 8 years down the line from here, each and everything around us will be connected with the electronic systems, even in our country, which are capable of making intelligent decisions efficiently, remotely, autonomously. And these kind of cyber physical systems or IoT systems are termed as what we call cyber physical systems. Now, I want to briefly also discuss with you that what is there in the name. The name cyber physical system, from where it came and how it all started. Since we are talking about, the so-called our development program, when I'm saying faculty development program, recently when I was talking about cyber physical system at a conference, they said that we have heard about IoTs, but we have not heard too much about cyber physical systems. Now, can you explain what are the cyber physical system? And that's why I thought of including the first slide that I was talking to you. And that's why I thought of introducing you in terms of how all this started. So if you look at when Nikola Tesla discovered the idea of teleautomation. So what we call IoT today, or what we call cyber physical systems today, it was termed as automation using the telephone, and therefore the term teleautomation came in 1926. Then in 1948, Norbert Wiener gave the very same term, a new idea, And because of the, cyber presence, he started calling it cybernetics. So 1948, the very term of cyber physical system was actually called cybernetics, with the very same idea of communication. Then Apollo guidance computer came in 1961. Charles Stack Draper given this idea. Then 1988, Mark Weiser improved the ubiquitous computing and talked U computing basically in short. And then in 1999, Kevin Austin called the very same thing with the little bit of advancement as the internet was taking over the entire landscape as Internet of Things. Now, the presently what we call cyber physical system. So Internet of Things is basically an old name. So when we talk about earlier, when we talk about Internet of Things or Internet of everything, right? The systems or the devices, they were directly connected to a control system. And from there, you were able to take decisions or able to take data or able to transfer the data. But in 2006, when it has been realized that these Internet of Things or the devices which are connected with internet can also communicate to each other, can take collective decisions, can collectively empower the entire communication system, then it has been termed as cyber physical systems. So if you want to read more about cyber physical system, please go to this website. Now, you may be thinking that who gave this idea of cyber physical system? There has been many big names, starting from Nikola Tesla, he was a physicist. And then comes the Helen Gill. So the lady seems to be an Indian from the name, but she is presently the program director for the Embedded and Hybrid System program of NSF, National Science Foundation, Directorate for Computer and Information Science Engineering, Division of Computer Network Systems, and United States. So she's the one who has given the idea of cyber physical system, or she has given the name cyber physical system, as per my understanding from the available literature. So with this, now I would also like to discuss with you that what is the national mission on cyber physical systems or interdisciplinary cyber physical systems. So recently, when I'm saying recently means in 2019, Government of India has launched a mission considering the aspects, considering the rapid rise of intelligent systems everywhere. Government of India has launched a mission of 3,600 crore rupees. And they said that they would like to grant 25 institutes projects which will be working in the technological advancement in the domain of cyber physical systems. And this was mainly done to prepare our country for the global advancement and global rise of the intelligent system in different domains. So be it technology translation or in the technology development, be it knowledge, be it development, commercialization, whatever. So be it any domain of, what we see around us, everywhere they felt like intervening through the cyber physical systems. The idea is that we do a lot of R&D in this area. We do train our people and skill people in robotics, AI-based big data analytics. You all know that big data analysis was one of the biggest, project pipeline, which was given by DST in past. And many of you, I'm sure, have the project which are an AI-based big data analysis. But government has now much more concentration on these areas. And they want that we academicians advance the knowledge of the people whom we are training for the extensive use of Internet of Things, and develop and deploy these technologies in the domain of agriculture and water, health. Remember, I was talking in the beginning itself that we can talk about health. We can talk about technology in the environment or for the environment. You can see the manufacturing. See, when we talk about manufacturing, we talk about Industry 4.0. And when we talk about Industry 4.0, we cannot avoid talking about robotics, the artificial intelligence, IoTs, and cyber physical systems. Because the manufacturing that you will be taking care of in future, it won't be purely offline. It will be all online. I want to give you an example on this particular aspect. And I'm sure all of you must be thinking that there are applications of IoTs and AI-based data analytics in industry or in manufacturing. Recently, we got in touch with a company called SEM Automation in Mohali. And what they do, they realized during the lockdown, and I'm sure that all of you will connect with this, during the lockdown, they realized that their industry is making some objects. They need to be counted. So earlier they were employing a manpower who will count the objects that we have produced 100 or 200 or 500 in the production line. But now they realize they are not a big industry. They're the medium scale industry. They realize that if we can provide, because during the lockdown, their industry was down and they could not find enough manpower to do that work. They realize that if there is a possibility, if we can remotely count and then close or start the operations on the basis of how many products are already produced in the factory remotely. So this is where the application of IoT and cyber physical system comes. And when we looked at their application and when we looked at what can be done with the IoT systems, we were able to deploy the IoT systems which are able to realize in the real time that what are the number of products that are produced today. And if they want to close or shut down the operations, they can shut down by sitting at home. They don't need to go to the factory. So manufacturing, environment, health, agriculture, and water, these are the big domains to deploy IoT and cyber physical systems. Now, when you look at infrastructure and the geoinformation systems, now infrastructure, obviously, so everything that we see is capable of helping our lives is coming into the category of infrastructure, as you all know. Then geoinformation systems, it's extremely useful today. Even for small things, see, when you are visiting a friend, you're always saying, oh, can you share your location with me so I can reach where I want to reach? Now, this is just a very naive example of what geoinformation system can do. And every aspect of the technology that we see here is connected with also national security. And every technology that I'm talking, and there can be many, they are connected with IoT and cyber physical systems. So just to give you a quick information that IIT Ropar has been identified as one of the 7 institutes in the country in the first phase, which have been, hosting the Technology Innovation Hub in the cyber physical systems. So we are presently executing this project, and if any one of you is interested to connect with us or connect with any of our domain, please feel free to communicate. Even colleagues from Punjabi University are connected with us, and we are working on what we can do together in the cyber physical system particularly for the domain of agriculture and water. But if it is in any other domain, that is most welcome. Yeah. So let's move to the next point. But if you have something, if you would like to, I will be very happy if you would like to ask something or interrupt me for something.
Participants are requested kindly unmute and you can ask the
Now,
questions.
if you want to ask something, I will be very happy, because see, this is how it can be much better. Okay. Or you can simply say hello.
Morning,
So
sir.
it's good.
There is an introduction session. No doubt, sir. You can proceed, sir. It's good.
Okay. Thank you, Santil. It's nice. Even what you said.
Good, sir.
Yeah,
no,
it's
sir, only introduction is going on. No problem. Okay. If you have any doubt,
yeah,
we'll.
That's good. That's good. So this entire discussion will be more or less like this. This is how we always feel that, at least how I think, that all of us are in the domain that we can sit and find out what we can do. But what is more important is we should realize what is going on worldwide and how we can contribute to different domains. Okay, so let me just move it to the next point. So technology verticals that has very high
Excuse me,
connect.
sir.
Yes.
Good morning, sir.
Good morning.
Very nice lecture, sir. And sir, I just want to know, is the networked control system and cyber physical system, are they same or have some difference between them? Because I am working on networked control system.
Actually, they're all same. See, this is what I was trying to say. This. Thank you very much for asking this, and this is how we can build a better program, because the network control system, as you rightly said, it is all starting from what I was trying to give the introduction from teleautomation. So teleautomation is exactly literally translating to what you are saying, network control systems. So cyber physical systems are nothing but the network control systems with additional advantage to them. The additional advantage to them is that you are not the sole, let's say, controller. If you make the cyber physical systems autonomous enough, they can also take decisions. So there are 2-3 aspects to it. One aspect that you just said, that it is network control system. For example, you have an air conditioner sitting at home and it is network controlled. So you are in your office and you can switch on the air conditioner that is sitting in your house. You can switch it off. Now, this is also a branch of cyber physical system. But what if your air conditioner realizes that can process the information that your location is now at office and you started from office to home, you will take 30 minutes to reach. And then this entire information is processed by the controller that is sitting in the air conditioner. And 15 minutes before you reach home, realizing and analyzing your coordinate systems and the time taken from that particular point to home, the air conditioner is automatically switching on. You're not even telling, you're only giving the input that you started. Or that input also, let's say your mobile phone in some way is moving and you somehow fed or tell your car or tell your mobile phone that take me to the home. And then this is another or high-end cyber physical systems. So the network control cyber physical systems or network control systems or the Internet of Things cyber physical system, computing, everything is same. But of course, when we add more, capabilities and features, then it keeps changing name. But whatever you said is perfectly right. So thank you very much for asking this.
Thank you so much, sir.
Yeah.
Good morning, sir.
Good morning.
Regarding this IoT, we are not able to understand the depth of IoT.
What is? Yes, yes.
We know, yes, just how to sense data, and after that, small amount of processing, then send to the further processing. If it is required more, then the cloud will do it. Then once again, action will be taken place at the destination side where the control to be required. So this includes even that cloud system and even networking, and how we supposed to go through, how much we need to understand.
So yeah, if I understood, see, this is very nice. If I understood your question rightly, you are trying to ask me that what is the depth in which one should go to develop a full-fledged IoT system
Yes,
or
sir.
a working IoT system. So when we talk, I'm sorry talking like this, but all of us are, as I said, all of us are in some way, experts in different domains. So what I'm trying to say is that when you want to develop a particular system, you typically ask question that what you are developing, and then what are the observables and what are the decisions you want from that system, and what are the operations you want from that systems to be executed. Let's assume you are developing an IoT system that only gives you information. Suppose you have a kid in a room, you want to leave the kid in a room, and then today we have IoT system available in the market off the shelf. You can buy a camera, which is just 2000 rupees. It has got an application also, and that application you can install on your mobile phone. Now somebody has developed it. So what are the operations that has gone into such an IoT system? The idea there was that you want to monitor something using an image sensor that is sitting inside the camera. And then there is a controller. That controller is able to move the camera in different directions by sensing the motion. So there may be a motion sensor. There should be a motion sensor there. Or so that the side of view is changing in the real time with the kid is moving. And then it is giving you in the real time information. Now, if this is the only requirement that you want to monitor in it, a kid in the real time, if this is the only requirement, this is sufficient. But if you want to put more requirement, for example, what if my kid is crying? Then you need a sound sensor. And then you need maybe, because sound sensor will have some kind of sensing system which can sense a particular pitch, okay, and particular sound. But then who will realize that kid is crying or playing or giggling? So if you want to put all those capabilities, you need artificial intelligence to access or to learn what kid is doing. And then you need the capability in the system that there should be an SOS if the kid is crying. And then your mobile infant, instead of vibrating, just vibrating, it should say that take care of your kid, it's crying. So when you talk about the IoT or cyber physical systems, when you talk about what should be the depth of development, the first thing that should come to your mind, what is my requirement? And the depth of the development will be based directly or will be related directly to what is your requirement. And then sometimes your requirements are very high. For example, I just want to give you an example. Suppose you want to do the same thing with the birds that are coming to your balcony or the insects that are coming to your balcony. And you want to understand what kind of, entomology is there around your house. Okay. sorry, I just got some kind of annotation. Okay, so then you have to implement the AI and machine learning algorithms to understand the type of birds. Then you need to analyze the data about the wing size, analyze the data about their frequencies, analyze the data about their sound. But then the question comes, do you want to transfer the entire data to the cloud? And if you want to transfer the entire data to the cloud, you need very high-end infrastructure. And if you don't want that, then you want to have a processor sitting right there at the system. So it depends what you want to do. And you want to transfer only a small amount of data, which can even be transferred to the cloud using a 2G network. Okay. So it depends what you want to do, what is your requirement. And when we develop any IoT system, or when we develop any kind of system, which is for public domain or consumer electronics, we always make it as simple as possible. So what goes to make it simplified from a complex backend system, that is also to be realized. So the depth, as you ask, the depth is not defined for all the systems. The depth is as per the requirement of the IoT system, and that kind of capabilities you would like to bring in. But otherwise, a typical IoT system is an extremely simple device that can be easily developed. Okay. So I don't know if I was clear when I was trying to give you an example about the depth of the system.
Thank you,
this
sir.
is how this is how I feel that it should be looked at.
Sir, another one, a little bit question, the small regarding we use the existing network, sir, for transferring data to the cloud. So there we are using existing network. So in this IoT also, could you use same network for all process?
Depends. Depends how heavy the processes are. You can have, see, many people today are talking about that we can use Wi-Fi. But then if you want to, I want to give you a quick example on that. So when you talk about the network or the connectivity, what kind of connectivity you want to use, or what kind of network you want to use. For example, you are developing, many of our colleagues, there is a team of colleagues at IoT Ropar who are involved in developing livestock, tracking system. So what this tracking system does, it takes the information about the cow, the temperature of the cow, or how many movements the cow had from morning to evening or in 24 hours. And then on the basis of this information, they try to build some information which is useful. Now, when we were talking about and when we were discussing about all this, the very question that you just asked came to our mind, that what kind of network we should use to transfer the data. So initially we thought, okay, let's do it with Wi-Fi. But then if you transfer such a large amount of data, if you have 1 cow, 2 cows, that is okay. But the moment you have 100 cows or 200 cows in the same area and you transfer by Wi-Fi, it is very difficult, highly energy consuming. So when I was trying to tell you in the previous question that what is your requirement, and you will define your network system, you will define how much data you want to transfer from the local host to the cloud, that you will decide as per your requirement. Now in this particular case, in case of cows, now then we thought, okay, let's do it with Bluetooth. Now Bluetooth is the best option. So what you do is you install a gateway, you transfer all the data, all the information from the cows through the Bluetooth. Now Bluetooth nowadays is quite high end. Okay, it's not like that you go on the other side of the room and you don't have the data transfer. So Bluetooth, and then you put your gateway. Now at the gateway, let the initial analysis happen. And then from the gateway, you want to push the data to the cloud. So depending upon what is your requirement, depending upon what you want to do and what is the quantum or size of the data, right? And how much information is sufficient for you. You will not need all the information from something. So you want to take only the information that is useful. And then you simply move your data from what we say gateway to the cloud. And this is where we are moving any kind of data to the cloud because we want to make it available for everybody. As one of our colleagues asked, that network controlled, systems. So then it goes. So the network also, this question that you ask, the existing network, be it 5G network or LoRa or LoRaWAN. So all these network systems, it depends upon what kind of system that you are developing and what is the purpose. Then you will use long range network or you will use short range networks. And then when you are using long range and short range networks, you will also look at or try to look at the aspect of energy. Because if you are putting the battery today, one of the biggest problem that we have in our mobile phones is the battery. So our 2-3 networks are on, some 5 sensors are on all the time, and then the consumption of power is very high. And as we are moving towards, from 4G to 5G network, again, we have difficulty and the data packages that are coming. So it depends upon what exactly you are trying to take and what kind of information, and therefore you will decide what kind of network you want to use.
Thank you, sir.
My pleasure. So I think if there are no more CIE, okay. Wait. I do not know the thing that I have been enabled. Can you disable me for this annotation if my colleague from Punjabi University is there? See this annotation thing.
Yes, sir. Yes, sir. I will do.
Yeah. The reason is that it is okay. I think because the moment I'm using it, I'm not able to move the next slide. So something, I guess I don't want this. See, this is the.
Yes, control is in your hands. You can inactivate at your end only.
So how do I do that?
Sir, on the top panel, there is the button annotation.
Annote. Okay. I did it. Very good. Thank you. So this is actually the answer of my previous question. So one of my colleague, let's say our colleague from this program has asked that what kind of network. Now this is one of the problem. So I had the annotations on my screen and I do not need them. They were complicating my life. And I understand that some of you might, use that perfectly. So it depends what is my requirement and I will use only that. Okay, so as per my requirement. Now, what are the technology verticals? When you look at the technology verticals, where IoTs and cyber physical systems can be directly used. There are many technology verticals where you can use this kind of cyber physical systems, starting from environment. You know that environment, this is exactly, you get the temperature information, you get the wind information, you get sunrise, sun, everything. And then this is connected also to agriculture domain, or this is connected to, this national security or anything. Environment is ultimately, since we are living in very same environment, so it is connected with everything. Environment, forest, and climate change. So this is where the IoTs can be used. The fisheries is one of the sector for India in particular, and I want to give you an example on the fishery sector particularly. See, when you talk about the fishery sector, India's fishery market. Now, why I thought of giving you this example, you will get to realize that this particular sector by 2026 in India is going to be 2,500 billion rupees. So it clearly shows that I'm saying 2,500 billion. Okay, now this is a huge money, and this money is going to be, generated through the fishery sector. This is the projection. So IoT has great potential in the fishery sector in particular. And what are the ideas and what are the potential domains? The potential domain is, if you talk to anybody who is doing fishery, they will tell you that if the temperature of the pond is rising, if the oxygen content in the pond is decreasing, they want it to be controlled or optimized in the real time. They want oxygen content should increase in the pond so that fishes can survive. And if the quality of oxygen, of the amount of oxygen in the pond is sufficient, the quality of fish is better. The same thing happens with the temperature. If the temperature is high, fishes start dying. So this particular sector need the IoT and a lot of sensory networks in it. For example, in fishery, you have an aerator. An aerator does nothing but it aerates the water. It increases the content or the percentage of oxygen in the water by aerating it. So when aerator should start, when it should stop autonomously, there is no human intervention in it. This is where in the fishery sector, you can bring in IoTs and cyber physical systems. And since the sector is very, very rich, if you talk to the people 20 years back, the fishes were not very much included in Indian diet everywhere in the country. Of course, in the coastal areas, fish was one of the food items, but not everywhere. You can take the example of Punjab, for example. Punjab was not eating fish a lot if you look at the 20-year back situation. But nowadays, you can find fishes everywhere in the state of Punjab. So this particular sector is increasing and advancing in itself and need a lot of IoT and cyber physical systems to improve the way people do the fishery. The food processing industry input. You see, the food processing worldwide is one of the sector which is contributing to the global GDP or contributing to the GDP of that particular country. Food processing in India is not very high. And because food processing is not very high, our food waste is very high. So when we talk about food processing, food waste is connected to it. And this is where IoTs can be and cyber physical system can be deployed. Rural development, land resources, skill development and entrepreneurship, textile industry, electronics and information technology, of course, by default, fertilizer industry, food and public distribution. Now, when you talk about food and public distribution, we have seen all these technology verticals where IoT and cyber physical system can be deployed. But when you talk about food and public distribution, you see today, I'm sure we are sitting here 103 people, and I can guarantee there is not a single person who has not ordered food using Zomato. Now, Zomato is a classic example of cyber physical system applications. Without having any kitchen, they are able to supply food to anybody. So the public distribution of the food, or you can say food and public distribution, is one of the biggest IoT deployment scenario or case. Atomic energy is another Niti Aayog on Earth Sciences. So there are almost, if I can say, that all these 13 technology verticals that I listed here, they're in a way or another connected with our life. And in every sector, the IoT can be used. Now, how we can do it? Particularly in line with what I was talking to you, that National Mission on Cyber Physical Systems. The directions from the government, or direction, when I'm saying government direction, of course, these are the directions from the Scientific Advisory Committee at the national level on the National Mission on Interdisciplinary Cyber Physical System, that use existing knowledge You don't need to reinvent anything. Whatever is available, we have enough knowledge today to develop smart products which are connected with cyber physical systems. You don't need to do R&D. You have to do the optimization of processes. You have to connect the devices, optimize them, simplify them, and then leave it to the consumer use. So this is how the entire cyber physical system can lead to. But then now coming to the point that I wanted to discuss with you, that what is the application of cyber physical system and IoTs in the domain of agriculture and water. I said in the beginning that I will be primarily concentrating on this area. So if you look at what is the genesis or what are the bigger issues that we all have to address. And bigger issues are, if you look at that our population by 2050 will be around 10 billion. When I'm saying our population means the world population will be around 10 billion. And that require 70% more food to be produced globally. Now, how are you going to produce 70% more food globally when the land resources are reducing every day? Now, this is where you need technological intervention. More than 30% of food produced globally is also wasted. So remember when we were talking here, the food processing industry, the application of IoT. This is directly connected to what we call how much food is wasted globally. Now, why this particular example is coming here? Why IoT and cyber physical systems are important? And in India, this number is even higher. We are talking about global food wastage. You go to any of our mandis or any place in the country, the food wastage is very well evident. So how can you reduce the food wastage? You can reduce the food wastage by having the systems which are connected and the systems which are at the local level, at the village level. And not only this is a problem, this is connected with the problem that the 30% food that we are wasting globally, it is also equal to 25% of fresh water. And we know that 65% of the people globally make a living through agriculture. And if you look at the agriculture scenario in our country, it is much higher than the global scenario. In India, agriculture connects more than 75% people. And therefore, if you look at the GDP, it is more than 20% of India's GDP coming from the agriculture sector. So when we were talking, previously, during my introduction, I said that the cyber physical system and IoT in the agriculture domain is a bigger issue than the cyber physical system and IoT in the technological domain. Because there is not a single sector which is contributing 20% of our GDP. Actually, if I look at the numbers more carefully, this number come out to be 23% in India. And 4% global GDP is being taken care of or controlled by the agriculture. So when we talk about some kind of systems, they should go to the bigger sector first. And the bigger sector that is directly connected to our lives. And if you look at the water scenario, the agriculture accounts for 70% of fresh water use. So the two areas that I personally feel are extremely important and demand a decent amount of R&D and deployment of IoT and cyber physical systems are agriculture and water. And the information that I'm giving here to you is from the Future of Farming or Agriculture 4.0 or Society 5.0 report 2018. Now, what is the then there are some other numbers that I don't want to go in detail, but I want to come to, let's say, considering the time, because we have one more hour. So it's better that I concentrate on the things that are much more important. This in a way I discussed with you that bird population, if reaches 10 billion, we need 70% more food. And then if it is related, then the amount of meat related food per capita by 2030 is needed is 45.3 kilogram. And this is also related to greenhouse gases and so on. But leaving this, the numbers I have already given in that small slide, that how things are moving. But if you look at the worldwide projection or worldwide, the contribution in the domain of agriculture and water, or the investment, you will realize this is the track of investment. Today, the investment is more than 400% from the 2012. This is the data up to 2015. I have data here. Even the biggest giants in the technology industry, like Bill Gates, you see the Bill Gates and Richard Branson, they will be supporting and talking about software industry. But they are one of the biggest contributors in the investment in the domain of clean meat. IKEA is one of the biggest furniture or the daily life brand. The David Cheng and the ruler of Dubai invest $14 million in Arrow Farms vertical farming. So vertical farms is another thing where IoTs and cyber physical systems are being used. So what I'm trying to tell you, just by looking at this particular slide, that agri-tech, according to the World Bank projection, agri-tech is going to gain huge amount of traction or huge amount of investment, much more than the software industry. So this is where we need to prepare ourselves for the future, particularly the colleagues who are working in the domain of Internet of Things and cyber physical systems. So just briefly going into what are the issues, let's say in Indian scenario, and what are the probable solutions in IoT systems. So you know that the issues, all of it started with the Green Revolution. Green Revolution gave us the, in some way, right to live, right to eat good. And it has started in 1950. In India, Green Revolution came in 1965. And it has been, very well received. Mr. M.S. Swaminathan is known as the father of Green Revolution in India. And our idea for the Green Revolution was that we will go for environmentally sustainable agriculture, sustainable food security, and preservation of biodiversity. And we coined this, that our Green Revolution will be evergreen revolution, not like the best. We will be very responsible citizens and will be a very responsible country in terms of when it comes to Green Revolution. But what has happened then in the due course of time in our country, and then this has direct connection with what we are talking to you today. If you look at that by 1970, and if you just see the delta T here, in 1965 to 1970, in a duration of 5 years, Punjab started producing 70% of country's total grains. So this was the scenario in 1970. And when Punjab achieved this, when Punjab achieved 70% of country total grain production, all other states which were nearby or anywhere else in the country, they started racing with Punjab and they started aspiring what Punjab has achieved in just 5 years of time. And how they wanted to achieve it and what they did, all other states, including Punjab, that they started using excessive amount of fertilizers and pesticides, because you have no other advanced technique to do agriculture. This is the only sector in our country where the technology advancement did not reach to the last person. The only ways that we identified and we realize are that let's use more fertilizer, let's use more pesticides, So pesticide because we want to kill the insects which are creating problems for our crops, and fertilizers to increase the yield. They were the two things that we could realize. And that has led to polluted waterways. There has been death of beneficial insects and wildlife, and the soil and water got contaminated. If you look at, or you talk to a typical farmer, they do more than 3 crops on a farm. And this become almost a practice. And because of the more than 3 crops on a farm, we used soil more than what it should be used. And that rapidly depleted the nutrients of the soil. And because of this, there has been practices like Punjab, if you see, if you look at the state of Punjab scenario, it was never been a rice producing state. And in Punjab, people started producing a lot of rice. And when you produce rice, you need a huge amount of water. So we had rampant irrigation practices, and that had degraded soil quality. Groundwater level has fallen dramatically. How the soil quality has degraded? Because we started pumping large amount of water from underground. And if we pump, the heavy metal comes. The other substances which are not good for health, they will come. And then you are using the soil for more than 3 crops, 4 crops or 5 crops, the soil quality degraded. As a result, the content of hazardous substances increases in the soil and water. And what we see today is that whatever we eat or breathe around us, or any other living being, everything got contaminated. So if you see, for breathing, we have now air purifiers, we have water purifier, we have everything purified. But what to do with the food commodity? Have you ever taken wheat flour to your home and purified it? Have you ever taken cauliflower and purified it, and vegetables you have purified it? So what is the sense of purifying just water? Most of the vegetables that you buy, most of the food they're also same quality, even worse quality of water that is coming to you. But you only purify the water. You don't purify anything else. So this contamination in the water, in the soil, is leading to the contamination into everything that we, or any living being, eat and drink, or even breathe. And as a consequence, we have now huge amount of health issues. Numerous are coming up because of this. So the solution is that the people sitting here today, they start working towards improving the very practice, the very agriculture practices, and the practices that we use in the agriculture fields. Start developing something, and that can be cyber physical systems or IoT devices that can, at least there can be 2 kinds of IoT systems or cyber physical systems. One, they inform you about what it is, and the other devices, they correct if something is wrong. At least if you have the information that this particular vegetable is not right, you will not eat it. For example, when they write, on the packet that best before 10th of November, on 11th, you will not eat it. That's what you see on the bread packet that you buy, and then you even sometimes throw the bread. You don't eat it. So at least you should have the information about what you are getting from the fields. So if you can develop an IoT device that can inform you about the quality of wheat that you are procuring, the quality of rice that you are procuring, the quality of vegetables that you are procuring for your house consumption. Now, correction is the second part of it. And if you stop buying, if people stop buying then of course the people who are producing it, they will also stop producing it. Then comes the correction part of it. So we can think about how we can correct it. And for that we need, again, some kind of technological intervention that may be connected with cyber physical systems and IoTs. So now this is one of the quote, and I want to impress upon all of you that once MS Swaminathan said that if agriculture goes wrong, nothing else will have a chance to go right in the country. So whatever we do today, we do, or whatever we plan for 10 years down the line, we plan it because we survive. And we survive because the agriculture is right in the country. But imagine a situation if agriculture is not right in the country or anywhere else, how we can think about tomorrow? How we can think about doing anything else but not the agriculture? So in our country, the best in general is good. They're doing better. They have all the information on the packets when they buy. In our country, this is exactly what went wrong. And I'm really wish to call upon that all of us start contributing in whatever way we contribute in terms of development of a small systems that can help people. See, today, when you want to test what is the pH of water, what you want to test, what is the TDS of the water, you have the devices that are coming in the market. But you do not have a device to check the quality of rice that you are buying. You just go, you look at the grain size, you look at if it is clean or not, you will simply buy a packet. You don't care about from where it is coming, how much is fertilizer used, what is the quality, how much radioactive substances are there. You don't care about anything of it. But you will, the very same person will never drink the water which is not purified. So this is called highest degree of contradiction. So our responsibility is, being academicians, that we train our students, we motivate ourselves to develop some IoT devices or some cyber physical systems which are handheld and can help understanding what you are buying or what you are eating. Okay. Now, so what are the, I just want to give you a quick impression about what we are doing at IIT Ropar, okay, so that you also get some feeling about what can be done at your institute. And if you feel like collaborating with us, we will be very happy to have you on board. So we are running, as I mentioned in the beginning, that we are running a project on agriculture and water, and we call it AVAD. So we call it Agriculture and Water Technology Development Hub. And this particular hub is given by Government of India with a grant of 187 crore. Our first transaction is 110 crore. I'm leading the project. There are 5 verticals of this project, which include water and soil quality assessment. So you see, when I was talking about that, let's develop some IoT systems which are able to help the agriculture and water domain. So our first technology vertical or technology domain is water and soil quality assessment. So if you can assess something, you can do something about it. If you cannot assess it, you cannot think about doing something for it. So one of the domain in which we are developing the processes and the cyber physical systems, IoT systems, for understanding the water and soil quality. The other vertical is water treatment and management. So here, we were assessing the quality in the first domain. In the other domain, we are developing the systems which can treat the water and manage it. So IoT systems can also be used for the management of the water. Then one of the vertical is stubble management in urban farming. Now, how you can manage the stubble? Stubble is one of the national issue. Everybody is talking about it today. So can you use the stubble for something? How can you use the stubble for making something that is not creating pollution instead of burning it in the fields, making fertilizer out of it? And can we use this very same stubble for urban farming? We should talk about water and soil mapping of hazardous substances. Remember, I was talking to you that when we talk about a lot of fertilizer and pesticide being pumped into the agriculture fields, we should also understand how much of this fertilizer and pesticide is going to our stomach or going to the food chain. So mapping is extremely important. For that, we are developing cyber physical systems to map such kind of hazardous substances in the soil and water. Then comes the digital agriculture. So when you talk about digital agriculture, remember I told you, I was discussing with you that digital agriculture today is what IT used to be 20 years ago. So the future of the information technology is the digital agriculture. You accept it or not today, but it is going to be this: agriculture automation and information systems. So this entire thing comes under the category of what we call digital agriculture. And then all of it, all the verticals that you see here, they are connected with what we call Internet of Things, IoTs. So all of these systems will be controlled, processed, used for taking decisions, will be connected with Internet of Things. So these are some of the technology verticals, and if you are interested, you can always get in touch. Some of the issues that we are trying to address in the domain of agriculture and water at IIT Ropar. In stubble management, we are trying to build integrated stubble management systems. And we are looking at commercial application of agriculture residues. That means the stubble that people burn sometime because they don't get the right kind of solutions. Modular systems for urban farming. Urban farming is very important. And I want to tell you that today people don't do urban farming because suppose if they have to go somewhere for a week, now who will take care of their farm? Watering it, take care of the fertilizer amount, take care of the nutrition in this, lighting and all that. So urban farming can only be a successful venture if you have cyber physical systems in place which can take decisions autonomously. Even though you are not there, you can control your farm by sitting in a relative's house, which is 300 kilometers from your own house. You will take care of it. You will have the modular farming system in your house or maybe in your kitchen. But today when you try to grow something, you are not growing it because you know that one day if you are not able to do it, it will die. Right? Then it comes the digital agriculture. So this is where we are trying to build the farm of one, where we are using artificial intelligence and machine learning to make informed farming decisions, AI-based approach to make food production more sustainable. We are working on consumer-oriented agriculture production matching, consumer dietary preferences, supply chain improvement and management. You know that in agriculture domain, supply chain management is one of the issue. And this is where you can use the cyber physical systems perfectly. So the entire digital agriculture economy, the adoption of robotics and technology in farms So this is where you need automation. You need the kind of automation that you need in industry, almost the very same kind of automation you need in the agriculture fields. Yeah. When you look at the water treatment and management, people are at our place, people are developing micro nanobubble technology for removing geogenic and anthropogenic groundwater contaminants. When one of your colleague, when asked, that what kind of network system, we are testing for IoTs. We are testing large area networks, that is LoRa. We are testing for medium ranges. We are working on Bluetooth 5.0 in IoTs. For very small areas, we are using RFID and NB-IoTs. So all kind of network systems, depending upon what are your applications, we are trying to test them for IoT systems. We are developing IoT systems using different kind of network scenarios. Then we are developing some of the cyber physical systems to accurate measurement of radio contamination in the food commodities. So you know precisely what you are eating, whether or not this is within the limit which is prescribed by WHO, World Health Organization. At least you can understand what you are eating. And then it is your choice. You want to eat or you don't want to eat. For that, you need the IoT help and cyber physical system help. Then there are more applications of IoT where you can also access to finance in the rural sector through AI-led credit and insurance underwriting. Right? So this is another thing that you can do. Now, when you talk about the biotechnology, so you must be thinking that in the IoT, how the biotechnology is coming. So when you talk about the future food, biotechnology will produce tastier food and more nutritious and eco-friendly crops. Now, to handle all of it, you need cyber physical systems. We need to connect farms and farmers, and we need to digitize them, make them smart. One of the example can be that you give the possibility to the farmers to know what they should produce, what they should produce that can give them better market next year. Often the farming or agriculture is being done on the basis of clear knowledge, on the basis of what is being produced by the other person. So all of it can be more, informed, can be more based on the knowledge, can be more based on the data. That we can very comfortably do using the digital networks and IoTs. We can improve the intimacy between consumer and farmer, and that can provide value for both. For example, some of our colleagues are working, just giving you an example so you can give it a thought. Colleagues are working on family farmer concept. So a farmer will grow what you want him or her to grow, so that there is a consumer ready for the produce that they are growing. And these people are connected with each other. Now, how they are connected with each other, you have seen Ola and Aware model. Now, can we have the same model using the IoT systems and cyber physical systems between farmer and consumer? This is what I elaborated here in the next point, that you can have harvest and deliver concept, on-demand farming or farm to fork model. Or even this same model can be extended to what we call seed to fork model. So even at the level when the farmer is going to seed something, the information is available in the public domain, through the cyber physical system. And then people can connect, yes, we are interested. And this will lead to the high quality food, sustainability of the food sources, and therefore it will directly be related and advance our health system. One of the things that I did not mention during the introduction, that food will increasingly and scientifically replace medicine. See, we eat allopathic medicine today. And we very well know that other than allopathy, all the medicine methods are primarily not the corrective medicines, but they are preventive medicines. So if we can include the food that has medicinal value in our daily routine, there are chances that we can be healthier. Of course, this needs a lot of R&D, but this can help, or this can be done only with the intervention of IoT and cyber physical systems. So with this, I think we can have some of the examples that I wanted to give, that we can have IoT-based smart irrigation and fertilization system. We can have surveillance of pests for the pest control. We can have harvesting time detection and communication. Crop yield prediction was one of the things that people were talking a lot. Detection of weeds. So you can make devices which can detect weeds and also correct it. You can have robots that can control the agriculture field, and you can have AI-based application to predict the market demands, and AI and machine learning based detection of pathogens and plants. So there can be a lot of things in this particular domain. Now, I think I will not go, let's say, from this too much in detail, but I'll tell you a few things before I invite you for questions and discussion. I would like to tell you that we have been running, this is an opportunity, let's say, for me to advertise one of our program, that we have been running something called online internship carnival last summer. And in this carnival, 100 internships are given to the student coming from all over India. You can motivate your students to apply for this program next year. And our plan is to offer 500 internships next year at IIT Ropar. Okay, and these interns supposed to work on a socially relevant problems in the domain of cyber physical system. They work on IoT systems, cyber physical systems, and these internships are paid. So they get also money. They get to live here at IIT Ropar. And just want to mention, the program has been supported by Dassault System, COMSOL, MATLAB, ANSYS, NVIDIA, and Moldex 3D. It has also been lauded by the Ministry of Education, by Government of India. And I'm very happy to tell you that from our previous internship carnival, we could generate 83 IDFs, and many patents and design ideas were filed. So this is a very ambitious program. And since all of you are faculty members, I request all of you and are in the engineering domain and in the probably in the IoT domain, you can ask and motivate your students to join our program at IIT Ropar. We'll be very happy to consider your recommendation. The other things that we are doing at IIT Ropar are, we are actually running a course every 3 months on artificial intelligence and cyber physical systems for agriculture automation and or industrial automation. And these two programs are being supported by Department of Science and Technology and our IIT Ropar Technology and Innovation Foundation. And that is why their fees is extremely low. So these the fees that we are charging, it is the fee connected to the hardware that we provide for the hand-on practice. The courses are free. So these courses also your students and your colleagues can attend, and they can advance their CV, not only advance their CV, but they can advance their knowledge. We have been running this executive course only on weekends. And this year, unfortunately, it is full. So there was more than 300 people attended this course and given certificates. Okay. So if in future there are people, excuse me. I'm in a meeting, please. So we have been, just to give you an impression that we have been developing the real life IoT systems at IIT Ropar. And if you look at this particular device, this is more like an USB drive. And this is India's first indigenous temperature data logger for cold chain management. And this has applications in the pharmaceutical companies, vaccine manufacturers, slaughterhouses, logistic and transportation, healthcare, and agri-food industry. So just to give you an impression about what this device can fetch to a company. For example, such kind of devices India imports of the number of 1.5 crore per year. Okay. Now, the cost of this device in India is in between 3,000 to 5,000 rupees, which are being sold. We have used the same IC and the hardware that Apple is using in their devices. And still, this device is very reasonably priced. And that is why it has been lauded. It has been appreciated by Ministry of Education and Digital India, as you can see here. So such kind of devices are very important to develop in the cyber physical system domain. Although the device is small, but has got really huge application. And whoever company will produce and sell it, they will be able to make huge amount of money. Okay. And this is, as I said, this is a real time temperature logger, and it range the temperature from -40 degree to +85 degree. And you can define the frequency of logging as per your requirement. And many ways that this device can use for body organ transportation, and this device has a buzzer. So if the temperature goes down or temperature goes up as compared to the temperature defined by the consumer or by the person who is using this device, it makes a beep sound. So you know that the commodity that is being transported or the object that is being transported, it has been introduced to high temperature or the lower temperature that was not required to be used. So this kind of devices, this is a very small device, IoT device, can be developed by any one of you. If you start working on this and of course go from TRL 2 to TRL 3, 4 and 5 and so on, and go up to 9. So even though this is a small device, but the cost of this device that we set it up is 400 rupees as compared to the devices that are being sold in India. So if you even multiply 400 by 1.5, and if I can tell you that when we kept the cost 400 rupees, we kept the profit of 50 rupees. So if you multiply 1.5 crore with 50, this clearly tells that you will get something like 75 crore rupees in the account if you are able to tap the entire market in the country. And today China and everything is stopped in the country, so there are chances that one can tap such a market. So even though you are not able to tap the entire market, even you are 10% of it, 10% of it can help you to build a company on IoT and cyber physical system. So for the future of students and for future of faculty member and to explain them what can this has been one of the example. Now we are doing a lot of other things, but I'll keep it short to take your questions. We are doing, this particular device is called MBTech, and this device is coming up in many other options, like it is also coming in the Bluetooth. We are developing something called extract, and this extract device will be telling you in the real-time soil and water contamination. Okay, Indus and Bias, these are the two systems that are IoT based, nanobubble generators for butter quality improvement. That we farm of one. This is another system that we are developing. It will be launched in March 2022. And this is basically a seed to kitchen farmer consumer network and cyber physical system that I was talking to you. The fishery sector I already discussed. One of the things that is very important, and I want to convey this to you, and will be very happy through this FTP network if we can connect with you. We have developed a 24 component IoT lab. So this particular lab is state of the art, and this kind of lab is not available anywhere in the world. People are buying, Arduino or Raspberry Pis or Red Pitaya or Jetson Pro, this kind of systems, and they are, some of them are expensive, even though some of them are not expensive, but they are not very good for industrial use. But the kit, the 24 module kit that we have developed at IIT Ropar, it can be used for industry directly, and this we are launching. We have launched. It's a very, very nice system, and it is certified by Seger controllers in Germany, and it has all the certifications that are required to take this or export this particular system to any country in the world. The cattle management system that I was telling you as an example that time, so we are working and this is ready. We have also something called Lava the Accelerator, which we are launching in January 2023. Through this, we can help people who have developed the IoT systems and cyber physical systems to have a bigger startup, and then they can go for making their own companies. The biodiversity sector, we are working, as I told you, that we are looking at the flying insects, and we have developed as a prototypes to detect their motion, detect their frequency, detect their images, and then process the entire information to give you the the right kind of information so that you can take decisions about the biodiversity. So with this, I think this is one of the things that I wanted to share with you, that one of our startup. So we also support startups. Now, why I'm telling you this, because this is the right forum where I can tell you so that you can tell students, be support startups of the clever ideas. And this was one of the clever idea where plant-based air purification system has been used. And this air purification system is using a peace lily plant and increasing its purification mechanism by 500 times. So when you have such a plant in your room, with this system, which is there, you actually have 500 such plants in your room. So these are some of the innovations that has been developed at IIT Ropar in the IoT Systems Lab, and we'll be very happy if there are people who are interested to connect with us. And please pass all the colleagues sitting here in the FTP, they can pass these words to the people, and if they are interested, they can connect with us. Now with this, what I will do is I'll take your questions. I will discuss with you because we have whatever 20 minutes we have left. In this time, we would like to build our discussion further on this. So thank you very much.
Thank you, sir, for providing a huge knowledge about the agriculture and water purification and plant purification, air purification plants. And now I request the participants kindly ask your queries or write into the chat box.
Yeah, that will be good.
Morning, sir. Good morning, sir.
Good morning.
Sir, I just want to know, as I am working in this networked control system, and also I'm looking for a project that is automation of a poly house, so that we can have an eye over the poly house through sprinkler waters and cameras and all these stuff. So how we can develop a middleware for all these devices so that they can connect with the my controller? Means which platform I should use?
Yeah, thank you. Thank you very much for the question. Allow me to receive a call. It's an important call. In fact, the director of NIT
Please, sir.
Srinagar is visiting me today, and he's on the gate. So let me just call him, and then I'm coming back to you.
Right, sir.
So yeah, your question is that polyhouse automation. Okay. Hello, can you hear me?
Yes, sir, audible.
Sir, we are audible. You are audible, sir.
Fine. So the polyhouse automation and the project that you are working now, you are saying that you want to develop the firmware for it, or what was the question? I actually briefly missed because of the phone. So
I want to connect my controller with all the devices which I'm installing in the poly house, so that they can detect and give all the data to the controller from where we can analyze the data. So what
so you
type
have more than one sensor, right?
Yes, sir, more than one sensor, right, sir.
Okay. So and what are the data that you want to take? You want to take
Sir,
humidity, you want to take the temperature, and
yes, sir.
you
We
want to
want to take
probably
the
take
images also from the camera sensor, sir, of the various parts of the poly house.
okay.
Like we can install 4 or 5 cameras, so that we can analyze the you can say the visibility of the or the color or texture of the leaves, so that from where we can
That's
analyze what type of diseases are there. I mean,
that's
we can estimate that, sir.
No, that's very interesting project. I think you should continue working on it. And
Right.
now coming to the point that what it can be. So you see the controllers that we use in presently. Okay. So even if I pick the best controller, I'm sorry, naming the controller here. It's coming from NVIDIA and it's called Jetson Pro. So this
Right.
is one of the controller that has been recently launched by NVIDIA, and it can be used for this purpose. But
Right.
I'm afraid that if you are willing to do it at the larger scale, then you have to have the gateway. You have to
Right.
have a proper computer sitting there, and then it should be able to take multiple inputs. Because the controllers that you use otherwise, they are good for less number of inputs. And the moment you increase the sensory network, then you need gateway and a proper computer designed for that particular purpose. So if you
Right,
are
sir.
interested, we are developing such a computer. Okay, I'm saying the processor, such a processor at IIT Ropar for a mega project in which we supposed to install 8,000 such devices across the Europe. Okay, so, and we are working with Bird's #1 company in the seed export, that is called Syngenta, and this particular project will be ready. This particular system or device will be ready by March 2020. And if you are interested for that kind of automation, you can always get in touch with us. And we will be very
Right, sir.
happy to give you such a device. We will always, will keep it also open source. So that is not a problem. But this cannot be done, let's say, using the off-the-shelf controllers that are available in the market. You have to have the full computer for that purpose when you
Right, sir.
have the entire sensory network. So like, people when they try with Arduino, this is out of the question. Huh?
Yes, sir.
The thing that can work for it up to a certain limit is Judson from NVIDIA.
Yes, sir.
And then you have to shift to a very customized system where
Yes, sir.
you are doing things as per your requirement. Yeah.
Right, sir. Thank you so much, sir.
No, nothing. So I'm actually because some of you ask the phone number, so I thought of putting here my phone number on the chat box. You can take it, and if you feel like, you can call or you can email me. I'm also putting an email ID that I am using, let's say, directly. So you can always write to us, and we will get back to you as and when it is possible. Yeah.
Thank you, sir, for sparing time and sharing the valuable knowledge with us. And kindly share the PPT with us so that we can share
We'll
with
do
the
it.
participants as well. And so you can leave if you are having any urgent meeting.
Oh yes, allow me to do it. Yeah, thank you very much.
Thank you so much, sir.
Okay, my pleasure. Yeah. हेलो सर, पुष्पेन बोल रहा हूँ जी। अच्छा, मैं आप मेरी उनसे बात करा दीजिए। कौन आपको रोक के रखा है क्या? मीटिंग में कहाँ हैं आप? अच्छा, मैं ठीक है, देन आई कम, थैंक यू।
Okay, so dear participants, shortly another resource person will join us, Dr. Preeta Sharn from Oxford Engineering College, Bangalore. Yes, she has joined. Ma'am, are you there? Dr. Preeta Sharn, are you there? Ma'am, I have given you the rights of presenter. You can share your screen, and for some time kindly switch on your video as well. In the meanwhile, I request Mr. Lakshmi Shankar to share the biography of Dr. Preeta Sharn with the participants.
Yes, good morning, all of you. Am I audible?
Yes, you are.
So I'm reading the brief profile of Dr. Preeta Sharn. Dr. Preeta Sharn is a postdoctorate from IIT Kharagpur, PhD from IIT Banaras Hindu University, and currently a competent professor with more than 22 years of experience in education, research, student mentoring, and association with international universities and organizations. She has responsibilities of teaching BTech and MTech students. She has guided 6 PhD students and 6 are pursuing. And she has also executed government and international agency funded projects. She is a self-starter with a strong entrepreneurial spirit. She developed R&D center for her own with a team size of 15 plus from the scratch. She delivered project for previous funding agencies across the world as lead investigator like Naval Research Board, DRDO, India, IEEE, USA, and Government of Karnataka, and AICT. With multiple patents in process, research publications reaching to more than 100 research papers under her leadership. She is visited facilities from leading universities like NTU Singapore, Tohoku University Japan, University of Macau, Limerick University Ireland. She has published papers in the premier journals and presented papers in IEEE conferences in Malaysia, Singapore, Japan, and Macau. Delivered lectures for VTU e-learning program via satellite for countrywide classroom. She has successfully conducted workshop in collaboration with IIT Delhi and IIT Bombay. She is the primary focal point and owner of all activities in her college as IEEE student branch counselor and site coordinator, and also associated with IEEE Humanitarian Technology Group. Recently, she developed a device concept for physically disabled person to operate computer that bagged the Best Design Award in the International IEEE IMRC Conference 2015. She has been awarded Woman of the Year in the year 1998 and 2009 by American Biographical Institute associated with Elsevier and McGraw-Hill publications as reviewer. So this is all about the brief profile of Dr. Preeta Sharan. So thank you. I welcome Dr. Preeta Sharan.
Yes, sir. Can you hear me?
Yes, ma'am, you are audible.
Okay. So now I will share my video.
Ma'am, am I audible?
Yes, ma'am, you are audible, ma'am.
Please, sure, ma'am. Kindly wait for some time. I think she has some network issues.
Yes, yes, ma'am.
In the meanwhile, I would like to share a few instructions with all the participants. I will share the attendance link after morning session and second attendance link in the evening session. Means in one day we are having the two attendance links, and that is the Google form. And I request the participants kindly join with only the registered email ID which you have registered at the ATAL portal, so that there will be no issues of the certificate at the end of your FDP. Because the participants who have registered at the ATAL portal, only they will get the certificates, and 80% attendance is required, and there is one quiz at the end of this FDP. On Friday morning we are having quiz session in which all type of questions, multiple choice questions will be there from the sessions which we are having in all 4 days. So if you people are having the queries, you can unmute. In the meanwhile, I think she will join us. Ma'am, you can share your screen with us. Ma'am, you are not audible.
Now I'm audible.
Yes, audible.
Okay, it's full screen. F5. My PPT is visible to you.
Yes, ma'am, you can make it full screen.
Okay. Yeah. Here. Yeah. Today net problem. Today only net problem. I don't know. Daily it was okay. Today first time. Now it's okay.
Yes, ma'am.
Okay. So I'll start now.
Yes, ma'am. Yes, ma'am.
Okay. Sorry for the internet glitches. Okay. So thank you very much for giving me this wonderful opportunity. And Ma'am, if I am not audible, please tell me.
You are audible, but your PPT is not clear.
PPT is not clear.
Yes, ma'am.
PPT, I can see my PPT here.
Ma'am, but
So I am,
we are not able to see. Yes, now it's clear. I think due to
okay.
that problem.
Now,
Yes, yes,
now
it's
it
okay.
is clear?
Yes.
Okay. Okay, ma'am. Okay. So I'll start now?
Yes, ma'am. Yes.
Okay. Just a minute. So, my topic is to give a talk on the design of photonic sensor for cancer cell detection, basically on the lab on chip. So here you can see that the title itself indicate photonic sensor, and second thing is the cancer detection, and third is the lab on chip. So first I would like to talk about lab on chip. So what do you understood by lab on chip? So lab on chip, it means suppose if a person is suffering from the cancer, then where patient will go? They will go to the pathology lab. So our intention is to bring that pathology lab on a single chip. So in my today's talk, you will understand how to design the chip for the cancer cell detection and how it will be help for the mankind and society. So this is the intention of the today's talk. So the total this lab on chip consists of the 3 steps. So in first step, what we will do the sensing mechanism. So it means our chip which we are going to design will sense the cancer, and then signal cancer, we will get the signal, and then signal processing, second step, and third step will be the display. So nowadays what is going on in the current scenario, a person who is suffering from the cancer, they will go to the hospital, and then in pathology lab they will find out, and few days it will take time, and then finally doctor will tell that yes, you are suffering from the cancer or non-cancer. So our intention is to devise the photonic sensor. So photonic sensor, coming to the photonic, so this is the three steps. So photonic sensor, next I will tell you. Photonic sensor consists of, net problem is there. 1 second again. Slide is not changing here. Today net issue is there. Yeah, be here. So, ma'am, can you see my slide is changing?
Yes, ma'am. Yes, ma'am.
Okay. So what is the methodology? So methodology, we are using photonic sensor. Backend algorithm will running for the modeling, okay, which is based on the finite difference time domain. And second, we are designing with a PHC, means photonic crystal based optical sensor. SPR means surface plasmonic resonance based sensor. So basically we are designing the photonic crystal based plasmonic resonance. So this and then we have simulation, and simulation based on the MEP and MPB software, which operating by using operating system Linux. We are writing the code for that to design the chip design. And then finally I have shown you the display. It means classifier, we are using nav based or AdaBoost classifier, and we will do the interface we have done by using Raspberry Pi, or you can use microcontroller or any other interfacing device. And finally, how chip will come by using the software IPKI software, which is the Python based programming. So this is what about the main methodology which is behind the photonic chip design, or else we can say biochip. So now what is the photonic crystal, or what is the optical sensor? How photonic crystal work as a optical sensor? So here you can see that photonic crystal, it is nothing but it is a periodically varying guide. Periodically varying guide means what will happen? it is photonic crystal is nothing but I will show you in my next slide. It's a holy structure. So in holy structure, how it looks like a periodically varying guide, I will show you in my next slide. So it will come under the broader domain of nanophotonics. So research progress has been done, which leads to development of the unique sensor. And total size of the sensor, why it is so unique? Because total size of the sensor is in the micrometer, sensing layer I'm talking about. After packaging, it will become millimeter, okay, or centimeter. But total sensor design, which we are going to do, and in coming 1 hour, I will show you, it will be the micron level, micrometer, which is 10 to the power minus 6. So you can imagine the size. And the main focus area of our investigation is sensor design, simulation, and analysis of the for optimizing the result. So basically, it will come, cancer cell detection will come under biosensor. And because we are doing the lab on chip, it means pathology lab on a single chip. So this is our main optical sensor. So now I will show you. So this objective already I told in 3 steps by the block diagram. This is the 3 step we have to do: sensor optimization, smart processing and display, and finally sensitivity enhancement. This is the basic block diagram of our work. So in the first block, you can see that optical sensor is there. This optical sensor, various researchers are working on photonic crystal as an optical sensor, fiber Bragg grating as optical sensor, SPR as optical sensor. So various subdivision are there which will act as an optical sensor. And next, once sensing mechanism has been done, then processing will come. So we are connecting optical sensor with the interrogator or optical spectrum analyzer, which will be a PC based sensor. And then photo detector will be there. We all know that in case of optical detectors, there are 2 types of detector: pin diode and avalanche photodiode. And finally signal processing, and ultimately we can see the display, cancer confirm or cancer not confirm. In this way display will come by using the Naive Bayesian or Adabush algorithm. So coming to the basic of the photonics, you can see photonic industry is very recent, and VLS is the mature technology. So difference between, so every time people will compare with the mature technology, which is VLSI. That current conduction takes place with the flow of the AC. Whereas in photonic industry, people are where current conduction takes place with the help of the photons. So this comparison between photonic. Now, when we are talking about photonic chip design, there is important role of engineering. So what we are doing, the code by the operating system as and writing the code in MIP with the open source software MEEP. So what we are doing actually, we are doing a defect engineering. So what is defect engineering? You can see now there are so many rods are there here. You can see so many rods are there. So these rods are symbolically actually holes. Okay, from the top view, if you will see, it will look like a circle. So if full red color, one line you will remove, this is called line defect. Or if yellow color, one rod you will remove, this is called point defect. So defect engineering is utilized to achieve numerous photonic device. And here we are creating 2 types of defect: point defect and line defect. This point defect and line defect, so this how to remove the rod, how to remove the one rod or whole one line of the rod. We are writing the code in MIP. So what we are writing and how it looks like, you can see this is the point defect. Actually one rod we have removed from here. So when we have removed the one rod, then it looks like a blue color light is allowed to pass, and it looks like a, you can see here, one rod is removed. So what is photonic crystal? I told you it is a periodically varying waveguide. How you can say periodically varying? It means, see, where black color dot is there, it means if suppose it is a rod air hole, and if it is a dielectric silicon, so silicon dielectric constant 12, and air hole means dielectric constant 1. So 12, 1, 12, 1, like this. Okay, so this is called periodically refractive index. Okay, so in point defect, what we are doing, we are removing one rod, so and light will allow to pass, then this light is passing and it looks like this. So when we can use point defect, when point defect sensor we will use, and when we will use the line defect sensor. Suppose if in water we have to find out bacteria, E. coli bacteria, so we will find out the size of the bacteria. The size of the bacteria, which is very small, of the order of micrometer, same size, we will remove the here rod. So in coding level, we will give the radius, we are telling radius, which is a circular. So same dimension we will maintain, and then we will allow light to pass. And then what will happen? We will allow through that water, and E. coli bacteria which is present there, it will struck there. So depend on the application, we are using the different defect engineering. Hello, can you hear me? Hello, I am audible?
Yes, ma'am, audible.
Okay, fine. So what I was talking about, that there are two type of defect engineering: basic, point defect, and line defect. Apart from that, any structure we can do like this. So basic, this is the point defect. So it is possible for us to remove a single column from the crystal or replace it with another one whose size, shape, or the dielectric constant is different than the original. So depends on the application, we will use the different structure. Now this is the line defect. You can see that one row of the rod we have removed. So how we will write the code? So in the code where we have defined dielectric constant of the silicon 12, we will define 1, 1, 1, 1. So what will happen? Then we will go for the run button. So what happened? One row is created. So it will known as the line defect. And Gaussian pulse light of 1550 nanometer, which is the visible range, optical range, will allow light to pass. So you can see that two diagram. So this is the first diagram. It shows that how we are doing by using the Ubuntu operating system and MEP tool. There are so many optical simulators are there. RSoft, Lumerical, Opti. Okay, many are there. So we are using open source. So you can see that in this way light is allowed to pass. Now what we will do in this line defect here, what we will do, suppose we have cancer cell detection. So what we will do, we will take the blood sample and we will allow one drop of the blood to put in the waveguide which we have created as a line defect, and then allow light to pass. Then in the outside, outer end where arrow mark is there, we will get a signature graph. Okay, and we will put in our database so that when unknown patient will come, we will check that it is matching or not. This is what we are doing for the cancer cell detection. So this is the point defect, again came already. So how to write the code, or how to go for the simulation? So you can see this is the flow chart. What we will do, we will start and we will define the input for 2D photonic crystal in terms of its parameter, such as radius. Just now I told, if depends on the application, if you want to go for finding the E. coli bacteria or AIDS virus, then dimension you have to define, and that dimension we have to put in the put for the radius and height of the rod, epsilon value, under root epsilon is equal to n, which is refractive index. That all value we have to define it. Then we have to run for CTL file, because we are working on the Ubuntu, so all of us know that CTL file has to run to get EPS and EZ file, and then convert the PNG image using this command h5 utils file, and then we will extract the data and we'll plot the graph. Now coming to the cancer cell detection. So one case study we have taken. where we are able to find out the basal cancer, breast cancer, cervical cancer cell. So this paper was presented and good citation we got. So what we have done in this paper. So I will talk about this, which is the today's topic. Okay. Today's topic was the cancer cell detection by using optical sensor. So cancer, we know that actually it is the leading cause of death worldwide, responsible for 8.2 million death, okay, since 2012. So we have taken the data from that 2012. It is expected that annual cancer cases will rise from 14 million in 2012 to 22 within the next 2 decades, as per the World Health Organization. So it is very important to find out early detection of cancer, because what happens when already doctors are there and people are going to doctor and they are predicting that you have cancer or not, then what is the use of developing this chip, photonic chip, for the cancer cell detection? The need for chip is because the patient, when they will understand and they will go to the doctor, that time it will advance and up to 3rd stage it will come. And after 3rd stage, as we know that very difficult to save the patient. That is why there is a need now, early detection of cancer. So how early detection of cancer is possible? By using the photonic chip. This is the next question. Okay, which I will try to convince you in my coming slides. First, I am telling what is the motivation, what motivated me to work towards this cancer cell detection by designing photonic chip. Fine. So early detection of cancer is important before it metastasizes through the body. Need for fast, accurate, and efficient sensor. This is the need of today's current scenario. Many people, I know that they understood, they got the symptom when it was too late. It was in the 3rd stage. So what are the existing methods used for analysis of cancer? Biopsy, which is invasive and painful. We know biopsy. They will cut the this one tissue, and which is the invasive. Invasive means pin pricking. Non-invasive means no pin pricking. So our photonic chip, which is a non-invasive. Okay. So this is the non-invasive. We are not taking any tissue or anything. Okay. So this is the, and then what is going on, existing method I am talking about. Physical examination doctors will do. If it is cervical cancer, they will do the pap smear. If it is the breast cancer, then they will do the mammography, and all those things are there. Then endoscopy they will do, depends on which cancer. If it is uterus cancer, endoscopy is important. Then imaging techniques like X-ray and magnetic resonance imaging, MRI they will do. So these are the methods. So what is the limitation of these techniques? So limitation means cannot be automated. It means it cannot be automated. Automated means after 1 step, 2nd step, after 2nd step, 3rd step. So there is a need now, because cancer is most deadly things, and survival rate after 3rd stage is very, very less. So researchers are going for doing this total detection of the cancer by automated. How we will do by automated? So still people are going for the research. So we are a part of those researchers. I can say with proud. Okay. So next, what limitation is? Cell subpopulation with similar marker expression are difficult to differentiate. How they are doing? How they are doing now cancer detection? They will see with the microscope, and I went and I saw in the hospital in Mumbai. So what doctors are doing? They are telling, just you see, these purple color colonies are there. It means actually how cancer will come. Each cell has to die actually. But what happened? Because of the cancer bacteria, cancer virus, what it will do? It will not die, and it will make a lump. And after that, if there are 2 types, one is the benign and one is the malign. So if it is a malignant tissue, no problem. If it is malignant tissue, it means after it will not die, and they will make their colony, and they will and doctor will check from the microscope that this purple color colony is there. Now it will become bigger and bigger, this colony. It means, how actually they are testing by the eye estimation. They are checking with eye, and they are telling. This is what the doctors are doing actually for the cancer. So they will check whether the cell populations, they are in a group and they are making a colony, and the color changes. These type of parameters they will check through the microscope in the pathology lab, which is very time consuming and expensive. So these are the limitation. What is the current scenario doctors are doing? So for that, people are going to do the research. So what is the aim? Aim is to develop a sensor which can be fabricated as a lab on chip sensor. I already told lab means pathology lab, and chip means what we are designing by using this MEP tool, by the software, optical simulator, simulation software. So that will come ultimately in the form of the fabrication of the chip. Okay, so that is called lab on chip for detection of basal, breast, and cervical cancer cell. So methodology. In that, now, which is very important to understand if anyone want to, work, research towards this. So the light we are using, because it is optical sensor, so the light propagation in photonic crystal depends on the refractive index profile. This is only very important to understand. If we have to find out the person is suffering from cancer or not. So doctor confirmed. Okay. So suppose I went to doctor who is having cancer specialist. So they told this is the blood sample of the person who is suffering from the cancer 3rd stage. I took that. Then I went to the pathology lab. And then that blood sample we got. So from the literature survey, what we have find out that the refractive index of that blood, you see now cancer cell blood sample is having refractive index, you see 1.39 to 1.40. Who will find out? How to find out? There is a refractometer. For the sugar, I have seen here in the DEBEL, India Defense Lab in Bangalore, for sugar concentration people, they are having a refractometer device, which I have seen, where if urine sample was put there, so through the urine sample, it was coming how much is the sugar concentration, refractive index value. Okay, if the person is suffering from the diabetic, like this, there is a refractometer which will read the refractive index of the blood sample if the person is suffering from the cancer. And there is lot of literature survey, lot of research paper is published where they are announcing that if the cancer cell is present, then the refractive index of the blood will change from 1.39 to 1.40. And if a person is normal cell, not suffering from the cancer, then the refractive index value is 1.35 to 1.37. So what we did, we have taken these two values. One is for normal cell and one is for the cancer cell, which values we have taken from literature survey. As the content of the cell changes, the overall refractive index of the cell also changes, and hence the optical property of the cell changes. We know that when we are talking about basic optics is telling that if refractive index is changing, then total overall the light path will change, and ultimately we will get at the output end shift in the wavelength. So shift in the wavelength will tell that whether it is the cancer cell or non-cancer cell. This give rise to change in the band structure in the photonic crystal, which is our optical sensor, which will modify propagating wave properties such as transmission and reflection spectrum, which will be very clear when I will show you. So what is happening inside? What is happening? We know that whenever we will talk about light communication, it means Maxwell 4 equation will come. So I will show you that with the help of that. Yes, you see now we have done the design. So this is the line defect, and in line defect we left 4 scattering rod. You can see that 4 rods are there. These are the 4 rods. 1, 2, 3, 4, 5. 5 scattering rod we left. This is one design we have done. We can remove those 4 rod also. Then direct light will pass. Here also light will pass, but we have purposefully, some reason is there where we have put the scattering rod for the higher sensitivity, to get the sensitivity. And then in this gap where waveguide is created, we will put our blood sample. So what we are doing in simulation, we are giving the value of the cancer cell. So you can see that. So what design specification we have taken for our simulation? We have taken the radius of the rod, okay, in nanometer, and then background refractive index we have taken 1, and then period of the grating. Period of the grating means the distance between the 2 black rod. Okay, that is the period of the grating. Everything we have defined, and dielectric constant of the rod is 12. Silicon under root 12 is equal to refractive. Okay, so all these design parameter we have given, and we have run the MEP tool. Okay, and we have done the simulation, and we got this output. So after that simulation result, we got simulation result after MEP tool. So MEP full form is Maxwell electromagnetic equation and propagation. Okay, so we are observing, you can see first cell, basal, normal cell. Refractive index we got from literature survey 1.38. So in the transmission frequency, which I will show you next graph, we got the value A by lambda, which is called aspect ratio, and normalized transfer we have calculated. Like this we have done for breast cancer with skin cancer, and then we have done breast cancer, normal cell, breast cancer cell, and cell, all refractive index value we got. And you see the graph now. Two graph are there. See, blue color is for basal cancer cell and basal normal cell. So normal cell is a red color. So in x-axis, frequency is there. In y-axis, power is there. So you can see that there is a shift. So if cancer cell is confirmed in a patient, it means if unknown patient is coming, then we will match it. If it is matching with the blue color, it means the person is suffering from the basal cancer. Or else if it is matching with the red color, it means the person is having the normal cell. Okay, this is what we have achieved. And next you see for breast cancer cell also, we saw normal cell, peak is you see very less, okay, lower position, and for the red color it is at a higher position. So we are getting two distinguished shift, so that we can discriminate between the normal cell and cancer cell for the breast cancer. And third one is for the cervical cancer. You can see there is a 2 different peak. So we can say that it is a person is suffering from the cervical cancer, or no, the person is not suffering from the cervical cancer. It means normal cell. So we have taken the refractive index values, and we have done the simulation. Okay. Next is the reflection spectrum. So that was the transmission spectrum. We know one equation is there, T plus R is equal to 1. So again we have run the MEP tool for the hello, can you hear me? Hello, I'm audible?
Yes, ma'am, you are audible. I request all the participants kindly mute your mics.
Okay. So in this particular graph, you can see this is the reflection spectrum. I was talking about transmission spectrum, because when we are doing the simulation, why we are doing simulation? Why can't directly we can fabricate? Because from all angle, from all the aspect, we want to make it clear that our chip design is accurate. Otherwise, to use one day foundry in Indian Institute of Science, Sense Lab is there. To use one day that foundry, the infrastructure is so costly. We have to maintain the clean room. Then we have to go for the lithography. FIB technique, all those machinery part, chemicals, all those, and the cost will be minimum 6 to 7,000. Why to waste that? So people who are going for making the chip, before only we should find out from all aspect that yes, you are getting the particular output. Because in Sense Lab, they will not allow. In whole India, 2 places this fabrication is possible in the foundry, where IIT Mumbai, one place, and one place in the Indian Institute of Science, Bangalore. So they want first to see the design. And if they are not getting this particular graph, where you can see that blue color, which is the breast cancer cell, and for the normal cell, red color. If two distinguished shift is not visible, they will not allow us to go inside the lab, because that design parameter, they want to make it sure. And then, because little bit variation will be possible, but exactly without any design parameter, they will not at all allow to go inside the Sense Lab for the fabrication. So what we are doing, we have find out first the transmission spectrum, and now in this particular, we are finding the reflection spectrum. So you can see that in transmission spectrum, how the graph is just opposite graph you are getting. Means here in this place where you are getting the peak up, here it is down. Okay, so one small part we have shown there, so it will be down. So T plus R is equal to 1. So we are very sure that, okay, our calculation for our simulation result is pakka, it is confirmed. As we know the basic physics, transmission plus reflection is equal to 1. So if you will overlap the two graph, we are getting 1. So all aspect we are checking first. So in the same way we have done for the breast cancer cell and for the normal cell. And next we have done for the cervical cell reflection spectrum. So first we did the transmission spectrum. Now we have done the reflection spectrum, just to check our simulation. From all the way it is matching. Okay, so this was our first case study, where we have taken basal cancer, breast cancer, and cervical cancer. And in this particular next case study, we are working for the lymphocyte cell. So what we are doing in this particular case study, we have demonstrated a 2-dimensional grating based photonic crystal based biosensor for complete analysis of normal healthy lymphocyte cell and its component for early stage detection of cancer in the wavelength range of 1530 to 1565 nanometer, which is in the optical frequency range, optical wavelength range. We know that now we are talking, you are listening to me to the optical fiber communication, which is in the optical range. Optical range will start from 1300 nanometer to 1550 nanometer. So this design is basically in the 1500. In 1500 also, particularly Gaussian pulse, we have taken 1530 to 1565 nanometer. So lymphocyte cell we are going to detect. So lymphocytes are white cell that are crucial to our immune system. These antigen prevents or even to kill cells. That it is very important to measure lymphocyte cells, which makes too many lymphocytes, WBC, RBC, so and very easy bleeding. Okay, so it is very important to detect this. So next. So what is the current industry state of art? Whenever we are going to design some sensor by using the new innovation, we have to check what is going on in the current industry state of art. So now what is going on for this type of cancer cell detection? So one method they are using, doctors, scanning flow cytometry, SFC. S for scanning, F for flow, and C for cytometry. It allows detailed measurement of the entire angular light scattering platform and required costly machine setup for fast detection of light. I'll tell you, I have read about this, what SFC do. we will allow blood sample, and then light will allow to fall, and light will scattered, and there will be a counter which will count the scattering of light, and based on the scattering, based on the flow of the blood cell and the number of count of the scatterer, which is the scattering light, they are predicting the person is having the cancer or not. This is what is the one technology for the SFC. Second is the fluorescence based method are not level free. So what happened in fluorescence based method, they will take the blood sample and they will put on the glass, everybody we know, and they will do the staining. So for that, and they will do the staining, and then they will use some chemical reagent which is called label. Labeling means LABEL, label. It means what? They are using the chemical reagent on the glass where they have used the blood cell for the cancer. So suppose if your reagent, chemical reagent itself is not accurate, it means if it is expired, okay, so if chemical reagent itself is not proper, then you will get the wrong diagnosis. It means a person who is not suffering from cancer, sometimes because of in the fluorescence based method, it will come, no, you are suffering from the cancer. That is why the patient will go for the 2-3 test whether to get confirm I have cancer or not. Okay, so these are the process. Now it's going on. Cell imaging method also people are using, where they are using the confocal microscopy, and they consider simplest model of mononuclear cells as a homogeneous pair, but in practical, nucleus structure is not totally homogeneous. So this is the problem in the cell imaging method. These are the doctors are using. Doctors are using the machine, but inside the machine, what technology they are using, I am talking about that. They will just put the blood sample. They will not know what is happening inside that. They will use the chemical reagent. If chemical reagent itself is expired, so then what will happen? These are the lacuna, and these are the current industry state of art. And methods are based on solving direct and inverse light scattering problem by using optical model of the single particle, which I told. So now, this is for the photonic chip design output. So you see in the table 1, we have taken refractive index and then transmitted output power. So what we have done, we have created the structure you have seen, where 3 rod we left in the line defect, and we allow the light to pass by taking the refractive index value of the lymphocyte cell. The value is 1.37. Okay, for cytoplasm 1.35, for nucleus 1.39. So we want to know that if this refractive index values are there, okay, so for the lymphocyte cell and its cytoplasm and nucleus and plasma, then we are getting the different output transmitted power, and we are getting the different transmission frequency. In table 2 represent the refractive index and reflected power. So one is for transmitted power and one is for the reflected power for lymphocyte cell, for the and its cytoplasm, nucleus and plasma. Because if that value, if it is in the balance form of the lymphocyte cell, and these are the value, so this will not cause a problem. Otherwise, if it is a cancer, then their values, refractive index values of the cytoplasm, nucleus and plasma will change. So you can see this graph. So we are getting lymphocyte cell average for the cytoplasm. You can see the color, red color is for the lymphocyte nucleus and for lymphocyte plasma. So as we know, in the lymphocyte count, we'll go to pathology lab, they will give the count for cytoplasm, nucleus and plasma. If within the range, how we are seeing our report, red color star they will put. It means it is out of the range and we will get scared. Okay, my parameters are not proper. It means, so in order to make this, we can do by our own, like how we are doing business by ourselves. 1 drop of the urine sample, if it will become 2, it means confirm, positive, means the lady is conceived, we can say. So that is our last vision. That is our last vision. So how it can be done? So by making this all graph inside our sensing, this is the sensing mechanism, and then we will put in our database, so that anything parameters values are different, so it will give, like there for the pregnancy kit, it is giving 2 lines, like this somewhat we have to do. This is the last vision, and this is the reflection spectrum. So I am only talking about the main technology behind the optical sensor. Packaging, I am not talking. I have not done the packaging. I have not done the final output. I have in my lab, what I have done, just I am showing to you. Simulation. This is the simulation for the reflection spectrum for the lymphocyte cell and its component. As I told, because of simulation, we have to do for the complete transmission spectrum and as well as for the reflection spectrum. And we have to make it sure that when we are overlapping these two, it answer will be 1. So if it is correct, it means we are ready for the fabrication. So we have done the sensor design. You can see the configuration, dielectric silicon rod in air, and sensitivity we got. Sensitivity we got 1000 nanometer per RIU. So you can see that, and quality factor is this. Now, this is very, very important to understand the quality factor. If quality factor is very high, you see 23,000, it means by seeing this only, our one design was accepted and ISC people told you can come for the fabrication. Why? On what basis they accepted our design? With the values. You see, we are getting quality factor 23,000. It means our chip is very good and accurate. It means confinement of the light is very high, because total size is micrometer. It means light should come inside and it should confine. If it is not confining within that, it means that quality factor is not good. So we have to go for the high quality factor. So in simulation, we have to make it sure that sensitivity value, see this 1000 nanometer sensitivity is really very, very high. So by seeing this result, sensitivity and quality factor, we can say that our chip is ready for the fabrication. What are the advantages? Advantages are, it will allow a wide design window and a wide transmission band, allow a wide PBG, photonic band gap, for polarization normal to the 2D plane, less Q factor as compared to PCRR. PCRR is another structure. I have shown you the structure of line defect. PCRR means photonic crystal ring resonator. So by using same logic, we can create, like how we are removing one line. Removing one line, what I told you, that in the code level, 12, we will do 1. So all 1, 1, 1, 1. So what happened? One line defect we have created by the writing the code in MEEP tool using OS Linux. So like this, we will create by removing the rod, okay, in the ring, so which is known as the PCRR. So what they are telling, if you will take that photonic crystal ring resonator, even we will get higher quality factor, okay. And drawback is realization of optical confinement is difficult as waveguide core is composed of air. So conclusion. The conclusion is the normal and cancerous basal, breast and cervical cancer can be differentiated easily and efficiently. As I have shown you, 3 different color graph was shown and shift in the wavelength was different. Then photonic crystal based sensor is designed and simulated for propagation analysis of lymphocyte cell. Lymphocyte cell is another cause of the cancer, and distinct transmission spectrum and band structure are obtained and analyzed. Distinct transmission spectrum and band structure act as signature for the respective biosample taken into consideration and can be used as refractive reference value for the further medical analysis. Reference value means what I told you, that you maintain the graph in the database, and if it is varying from that graph, so you can say that a person is suffering from the cancer or normal cell. Now, so up to here, I was talking about cancer cell detection. Now, what I have done in my lab, I am showing you, I have developed one device. So basically smart sensor. Smart sensor means when we will talk about, I think I have time, 15-minute time, na ma'am? I have 15-minute time.
You can speak around 1:30, ma'am. We
Okay,
have started
fine.
12 and you can speak around 1:30 and 1:30 to 2:30 we are having the lunch break, ma'am.
Fine, no problem then. Okay. So till now I was talking only about the sensing mechanism. So sensing mechanism means any sensor will be sandwiched. We know because we are following the footstep of the VLSI. In VLSI also we are doing the same thing. So we engineer will work on the sensing layer, and this sensing layer will be sandwiched between the substrate layer, silica layer, and top of the oxide layer, and then it will act as a sensor, complete sensor. So that different group of people will do, but overall how it will look and how it will be done, I'm showing. So next level is, so once suppose sensing layer is working, say how sensing layer is working, you can see just now I was showing you the graph with the help of the two graph. It means cancer graph and non-cancer graph. You can say that yes, uh, your design is very pakka, and you can able to say it is a cancer, it is a non-cancer, with the help of transmission spectrum, with the help of reflection spectrum, everything is ready. Now going to the second level, starting first slide I have shown you the three process. Second is the smart sensor. The word smart means what? People are going for the automated word means what? This is what I was telling. Doctor has to go one place to another. First is the pathology lab, then take the report. After 1 week, then go to the doctor. Then doctor will see the report. Then third, go to the, for next, if you have to go for MRI, or if you have to go for endoscopy, all those things are there. So it is in the break discrete wise. It is not automated. So now our medical things are not automated. Okay. So we have to go for the automation. So how we will do that automation? Okay. So for that, so we have to go for automation. So what we will do? So this particular slide will tell you next level how we will do. So light source, I told 1550 nanometer we will use light source, 1513 to 1535. That depends on what refractive index value you are taking. So light source we will use. Then optical waveguide. Optical waveguide here is nothing but structure what we are making. Either you are making point defect or you are making the line defect. These are the optical waveguide. And the detector. Detector means actually optical spectrum analyzer. If you are using fiber Bragg grating, it means interrogator. Depending on optical, it means I told optical will be different subdivision. Which optical sensor you are taking? I talk about photonic crystal based sensor. Then light detector will be optical spectrum analyzer, OSA. If I will take fiber Bragg grating, then I will take interrogator as a light detector. Depends on what optical waveguide you are taking. This is overall smart sensor design I am telling. So depends on what optical sensor you are taking, your light detector will be accordingly, it will match. Okay. So this is what total, it consists of 3 key section I can say, any smart sensor. Okay. So now what we are doing, I am showing. This is just the main workflow of any optical sensor. You can see that this is what we have done. So in my lab, this is the, everybody know, it's a Raspberry Pi. In that, what we have done, output came, output graph came. Just now I was showing you cancer graph, red color, blue color. That we have done the output through the naive-Bayes or ADA-Boost algorithm. And finally, we did not for cancer, we did for the water salinity. So we have find out the salinity. So it is coming display, you see, salinity, water 1000 ppm. Okay. So this we have done. In the same way, anything, it will come cancer, lymphocyte, or breast cancer detected. If we want, we can write the code for that. How? So see that. So we have to use the processor used to run the MATLAB routine for the machine algorithm. And that machine algorithm I told, okay, naive-Bayes and AdaBoost machine algorithm we are using, and LCD panel to display the result. Now, once our design is pakka, either next step. So we went to Indian Institute of Science. Okay, sir, my design is ready. I got transmission and reflection spectrum is equal to T plus R is equal to 1. I am sure from my side, everything is okay. So next level is, so there are two ways of doing any simulation. One way is take the open source, which we have taken MEEP tool. Another way, in my, actually I got lot of funding from the different funding agency. So I got from Naval Research Board, where 25 lakh funding was there. Out of that, in 14 lakh, I purchased RSoft. So RSoft is a licensed version. Why we should waste 40 lakh rupees? Imagine purchasing software, open source that. Answer is, if you are using the open source tool, then you cannot make the GDS file. If people, some of the attendees are from the VLSI domain, they know that how we are doing a VLSI lab. Actually, we are writing the GDS too in the ASCII format. And if it is the licensed tool, Cadence tool we are using, Mentor Graphic we are using from Synopsys company, then save as, if you will do save as file, it will save as GDS2. Then direct you can send. So what I did, I contacted, because here there was a queue for Indian Institute of Science lab. So I contacted Belgium University, Ghent University. So they told, okay, you send your design, we will do the packaging. And how it looks, you see that it looks like this. So in the system level, how your chip will look, you see line defect is there, you can see that is the line defect, and there is a 2-port input port and the SiO2 is the output port. So using input and output port, and on that we are putting the analyte. Analyte means our blood sample, okay, silicon slab. So now what happened, you can insert the port. It means it is this is the look, how lab on chip look. If at all anybody will ask the question, I will tell you this is what it looks like. This is called lab on chip, where on the top, this is GDS2 file. After GDS2 file, using the IPKIS software with the Python base, okay, they have done. In RSoft, directly you can do this, which I am having in my lab, RSoft. For single license, I have taken complete RSoft in 2015, 2012. I have taken 3 tools only, BeamProp, ModGrating, and Full Wave. These are the name, like in MATLAB, how it is, Simulink, you know, DSP tool, like this. In RSoft also different tools are there. I have taken the 3 tool, which cost 14 lakh. Fine. So this is called, this is how it looks like. Okay. So you can do by using the Python programming or by using the RSoft tool. And now we are ready for the design. Just you send it. So so we have find out the 2 different way of finding fabrication. One is be in the queue, which is a free for the government of India, given in the Indian Institute of Science, or else you send it to the foreign university. So we found that Rochester University, US, also fabricating. If we will give with the licensed version of software, they will do this fabrication, and in the Ghent University. So I am showing you smart analysis, how we have done by using the water, which is not done by cancer. For water I have done. So you can see that this is my scholar paper. You see, by using this naive-Bayes and machine learning algorithm we have used, okay, and how we have find out, you can see. So we have done for water, same thing, water will replace by the cancer cell, and we can use it for the cancer cell detection. So you see that light source is there, and MEEP tool is there, and finally it will go to the classifier, naive-Bayesian classifier, and MATLAB finally, and that MATLAB we will dump on the Raspberry Pi. These are the design parameters we have used. This is the light passing. You see, this is the ring resonator structure. You can see that how light is passing. This we have done by using the open source MEEP tool. So open source MEEP tool, anybody can do. You see how light is passing. To get this design, this iteration, we have done a lot of iteration where we were not able to get the light confined. Here in this particular structure, you can see that how light is confined, you see. So two port is there, one is the input port and one is the output port. Light started passing, and in this waveguide circle and the line, you put the blood sample and you will get the output if for cancer we are doing. But in this particular work, we are doing the water potability. It means we are finding the percentage salinity of the water. How much is the percentage salinity which is required to find out for finding the calculating the TDS for the drinking water. So we have taken the salinity of water 0.01%, 0.05%. As WHO, we know that salinity of the water should be less than 0.1%, okay, for the drinking purpose and for other purpose. So it is very important again to find out what is the percentage salinity. So we have done the optimization because today's topic is not for the water. So I will not go in detail of that, but just I'm showing that the second part of the signal processing, how display part will work, the same logic will work. So I was showing you, this is the smart analysis of the water potability. And again, I'm telling, because today's topic is for the cancer cell detection. So in place of water, we will take the cancer cell and the same workflow will be there. So you can see that how we are doing. We are taking the output from the MEP tool, and which will go to the classifier, and then classifier output will go to dump to the Raspberry Pi, and finally we will get the display. So you can see that enter the training data in USB and enter test order. So we will get, you see, so result came 2000 ppm. Okay, so the moment we will enter the data, so it will tell how much is the salinity of the water, unknown water. So which we are, this is again for the water I have done. I have not done for the cancer cell detection for the display part, but it will work. Okay, so in this way I can say that now we are thorough from starting from the one end to other end to end. End to end means how we started from the sensing design, then we got the graph and transmission reflection spectrum. That graph we have dumped, that graph will act as an input for our naive-based classifier, ADABUS classifier, and that classifier routine we have dumped into this Raspberry Pi, and finally we got the output. So in place of this, you see 1000 ppm, which is telling, this is what we are writing in the code, low salinity. So if at all we have to find out cancer, non-cancer, it depends on the values which we are getting. It will say that cancer in first stage, cancer in second stage. Same thing, how it will say? Because we will take the refractive index value of the early stage cancer, and then we will do the simulation that we will put in our routine for classifier. And if we will take for the third stage, then it will say early stage cancer detection, which we have not done. We can do like the same thing which we are doing. 2000 was there, it was telling that high salinity, and if it is 1000 ppm is there, it is telling low salinity observed. Okay, so this is the conclusion on the output. So now actually I have finished the talk, and just for giving the motivation, I will tell something else which is important for the researcher. I hope everyone, so many you can see that international conference and all I attended. So I am showing you about my lab. So anyone who is interested, they can collaborate. I am working on different domain. Quantum is also one area of research where we are designing the quantum chip. Like photonic chip design is there, like this quantum dot based chip design we are doing, and we are working in optical networking. Then we are working in the biosensor, and we are working on the railway monitoring, which I will show you. Just I am showing. So this is my R&D center, and these are the funding agency which we got the funding: Naval Research Board, NRB, and DRDO, then IEEE, we got the funding, and BGST, we got 2-3 times funding, and ICMR, Indian Council of Medical Research, I got the funding, where we have developed in ICMR funding, we developed one specs, and the specs was for what purpose we have developed the specs, I will tell you, and it will motivate you to write the proposal for getting the funding. So 20 lakh funding is very easy to get. What we have developed that if your hand is cut from here, half, so how you will move the mouse? Okay, so in order to move the mouse, what we have done, we have developed the specs. You have to wear the specs where if cursor has to, because your hand is not there. If hand is there only, I am touchpad I am using. So by wearing the specs, you move up. So cursor will move up, down, cursor will move left and right. So you just move your head and cursor movement will take place. Then talking about right click and mouse left button and mouse right button, how you will do? You just blink your right eyes and open. So how much you are blinking and open, that also we can control. In microcontroller, we will do the programming based on that, and then double click action will happen. Okay, so with the help of our head movement and eye blinking, we can able to do the normal work, and this work was well appreciated by ICMR people. I visited many times in Safdarjung hospital offices there in Delhi. So they are very kind enough. Government of India, I'm really very much grateful. Due to that, only in my this research center, I have created lot of infrastructure, and this time I got AICT 20 lakh RPS funding, where we are developing everything. All the funding I got in optical domain. In AICT, what we are doing, railway model is there, a railway train. It is fixed, otherwise I can show you. We have the model of railway train where we are passing the railway track, which is scaled one. Actually, railway one wheel is in ton. So we have scaled down to 5th%, 1/5, and railway track, everything 1/5. And when it will pass, so derailment, we want to see for the safety of the passenger. So how railway wheel will become flat. Actually, it will pass through the various time. So wheel will become flat. So what we are trying to do that when it will become the flat wheel detection we are going to do. So this flat wheel detection, how we will do? Flat wheel detection we will do by passing it optical sensor. We will put fiber bracketing based optical sensor. So we are pasting on the railway track and wheel will allow to pass. Actually, this work we are doing here, Government of India, RDSO, Lucknow, they have given funding to Indian Institute of Science. One company, a startup company is there for the 2 crore, and where I'm also part of the people and in the advisory, and where actually when train is going to Rajdhani Express and Prasanti Express, they are crossing the train. These 2 train they have given timing also. So when they are going towards the Chennai, so what happened? Rajdhani Express, we have already pasted the fiber bracketing sensor. So you know that in a railway there are so many wheels in the train. Which particular wheel become flat? Railway station master will able to watch sitting in his AC room aram se. No need to go for the manual testing. Sometimes because flatness will start from the millimeter. All research we have done. Actual train, we went there, railway station, and we have seen. So what happened? We can able to check that. We can able to check that whether it is the flat wheel is there or not. We can able to test. So those things, by seeing that idea, I have written for the lab version of the train to do the various experiment. So what are the various experiment? Just I am telling what I am working on the research in AICT RPS. Flat wheel detection I am doing. Then I am finding out weight of the loaded and the unloaded train. It means if the train is passing, okay, how much is the loaded and how much, it means what is the weight? Why it is required? Because some railway is losing the revenue. Same rate they are giving for private company. They are using the railway track for the unloaded and loaded train. So somebody has to find out how much exactly is the weight, that much revenue should come to the Indian Railway. For that, they have given RDSO Lucknow, which is having the main statutory body for the railway. Okay, so we have find out that also. So same thing we are trying to do in our lab also. Okay, so that it will support there in the actual. So like this 4-5 things we are able to find out: flat wheel detection and weight of the loaded and unloaded train. So these are the, if you can find, if you will write the proposal which will be helpful for a mankind and the safety of the society, then you will definitely get selected, because a lot of people, I am giving talk on how to write the project to get the funded project. So I am just giving you the tips because you are attending my uh, this talk, so it will be helpful, because nowadays it's a great demand actually, to get the funding. So in and VGST project I got 25 lakh this year. So for that I am making for the hand grip device. I am suppose a hand grip, this my hand, suppose here rod is there in the hand, so your grip is different. I am a normal person, my grip is different, so we are developing a device. So for that, Government of India, KVGST, which is the DST part, they have given the 25 lakh funding for device development. So we are trying to do this and put pressure, okay, which is all related to the mankind. Okay, and just and next I will show you talking about my research. And these are the award and all will come when you will do some research. Definitely, these things all outstanding. Some many people, many forum, research findings are presented and lot of awards came. So many patent are there. 12 patent is already filed and 2 are granted. And so many places overseas travel. The purpose of showing this slide is again a motivation. So what is the motivation behind this? Because see, it's written, I visited many country. So people may say, no, I can't visit because money matter is there. No money matter. I can say with proud. And I am educating and motivating the researcher who want to present their paper. See, in 2012, I went to NTU Singapore. It was totally funded by the Naval Research Board, DRDO. So how actually it was funded? Because when you will write the proposal, in that travel grant will be there, and in travel grant you can utilize that travel grant for the overseas after taking the permission. Okay, so you will get the complete name. Then I went you can see the top 2013 is written IEEE R10 project, where IEEE Women in Engineering, they funded that time tsunami came. I went to in Japan, Sendai University, where Tohoku University in Sendai, one place in Japan, just after the tsunami. So my research was for the drinking water. So it was matching with the IEEE R10 theme, okay, which conference conducted in Sendai. So any work which is, again I am telling, which is related to the mankind and humanity, because that time drinking water was the problem in that. So that conference was conducted, and again travel grant was taken care by WIE, Women in Engineering. So 3 months before you have to apply. And third was in the Malaysia, and fourth was in the Macau. TENCON conference was there. You can see left side, IEEE TENCON in 2015 I went there. It was totally funded by SERB board, Science and Engineering Research Board. So again 3 months before, and if it is the tier 1 conference, it will be granted. Even for the student grant is there. So even student want to travel, so 3 months before, if your paper accepted, you can just write a mail, okay, to the Government of India, SERB, UGC, AICT, everyone are very kind enough to give the travel grant. So these are the different places. Last I visited to the Ireland, University of Limerick, where I was the keynote speaker. So thank you. So I finished a little early, but you can ask the question. Yes.
Thank you so much, ma'am. You are a motivation for for beginners. You have a lot of achievements in your career. We will be getting motivated from your profile as well. Thank you so much. And I request the participants, if you are having any query, you can unmute and ask your questions.
Hello, ma'am. Dr.
Yes, sir.
From Institute
Yeah.
of Engineering Management, Kolkata, ma'am. So, a wonderful lecture, ma'am, from your side, and it was a pleasure listening to your so much activities, and we are highly getting motivated from you. Thank you, ma'am.
Thank you, sir. Thank you very much. Thank you. My intention is always to not only to give the lecture, but to tell, because many people are asking how you are getting the funding, how you are getting the travel grant, how you are finding, how you are patent filing. For everything, there is an answer actually. And many people do not know. That's why. See, if you have to write a funding proposal, always you have to write the topic which is directly related to the humanity, means mankind. Somebody will tell you, you define research. I will give the answer or definition of research is for betterment of the society. Because today you see, because of the good research work, our call rate is so low now. Telephone maximum research happen in the telecom industry, and you see today the call rate. Long back when I was there in BHU, I know that we were waiting for 1/4 rate. Then only we will call to our hometown. But now you see, anytime you can do. No 1/4 rate, and in the call this one call rate, because of the technology, CDMA, FDMA, you see the latest Suman, GSM, all technology. So always you write the proposal for related directly to the mankind. ICMR I wrote for the handicapped people. So definitely it will get accepted. So I am always choosing the topic which is directly related to the mankind, and try to collaborate with the industry. These two things every researcher should do. Now my this patent which got approved, which I filed in 2013 for my first PhD student, Poonam Sharma. She was working on the diabetic patient. She has done all possible diabetic, means type 1 type sugar, type 2, type 3, with taking the blood sample, with taking the urine sample, with taking the sweat, then tears, and she has done the complete analysis. That only we filed the patent. Now it got approved in after 7 years. Then Bosch company here in Bangalore, they are ready to take this. I'm happy to say, because we keep updating. So what happened, if you are attached with any company, then actually just I am telling from my personal experience, so that if you are there in Chandigarh, or if you are there in Patiala, and some medical healthcare company are there, or else I can also share. You have to attach your work now with your company. Otherwise, we can't grow. And real things will not come. Our work will be only in the paper. I have published till now 19 SCI paper. SCI paper is very much important for getting the funding. These two things you should know. If in your career SCI paper is not there, very difficult. And your paper you have to publish in the same domain. These are the tips for getting the funding, because many people are asking me, that how to get. And once fund will come, you will create the infrastructure. In my R&D center, complete this R&D center, this room where I am sitting now, it is totally funded by different till now 1 crore 67 lakh total funding amount I received in since 2011. Yeah. So anybody want to collaborate? Anybody want any guideline?
Ma'am,
Yes.
with your kind permission, ma'am, again. Ma'am, actually, many of our students actually working on different projects, not only in biomedical but in other field also. I am coming from mechanical engineering background. So, ma'am, actually thing is that writing patents sometimes become very difficult. Some of the students have their knowledge, they are, or some researcher, we are working on the group, we know how to do, but writing patents become very difficult. So, ma'am, if you can share your email ID, so some of our students, if want to contact you, ma'am, can you help in this regard?
Now immediately I will tell you, immediately right now I will tell you on spot. My latest one PhD student I am guiding, his name is Anup Upadhyay. He is from mechanical background, BTech, MTech mechanical. He is working here as a junior most faculty in my college, Oxford College. Now from MIT University I am guiding. Okay. Now he is in the mechanical. We have filed the patent, 2 patent we have filed in the optomechanical behavior of the grating sensor. So what actually happened, what you have to do, first thing is, you have writing the patent means any paperwork you do, like research paper, simulation, suppose for example, simulation work you have done, and you have got the graph. What you have to do, you have to write 4 claims, claim, 1 paragraph, 4 claims. Suppose 4 findings you got, okay? Suppose my mechanical that Anup, he has basically worked on the MEMS technology, optical MEMS technology. Okay. So by using optical MEMS technology, how he is able to find out the tumor in the brain cell, how with the optical MEMS, he is trying to find out tumor. So that result, you should not publish. What are the findings you are there? You have to put it into the 4 claim or 2 claim or 1 claim. It means that is your copyright, that is your claim. And first you give for the patent search. Patent search either you can do by your own, or you 5,000 they will charge, Government of India, and they will tell, no, you are thinking that first time you are finding with the optical MEMS tumor cell in the brain tumor cell, you are thinking, that is your thinking. But I will show you there are 40 link which is matching. You tell me now how it is different. Then that 40 link you have to search. Then you may find, okay, they are also finding the brain tumor by optical sensor, but not by using the optical MEMS. Understood? So this is the way you have to go in first step, that find out the, how to find out the patent search. Patent search you have to find out. You, whatever innovation you have done, whether anybody has done in the world or not. If any one parameter is new, then your work is patentable. This is the way we have done the 12 patent. You can write by your own. Now we have done hand grip device. So hand grip device, I can just show the hand grip device. I can show now. So some by using 3D printer, we have developed the hand grip device, one device. That device is not done by any of the, many other devices are there. We checked in the Amazon, we checked in the, but we have only designed by using CATIA, because you are mechanical. So I am lot of mechanical. Tomorrow my again talk is there in different forum where I am talking about all the mechanical things. So see that, see, just now I'm showing you also. See that this is the hand grip device. You can see that. So here we are using that sensor, okay? And you see that this design is done in the CATIA. You see that. This is 3D printer. Here rubber will be there, and that we are using the optical sensor. So how much pressure we will apply here? So my hand is normal, I can apply and it will go stretch, because it is elastic is not used now. So we will use that, okay? So how much is the expansion, and this, how much is the strength in my hand? Is we will make actual device by making the aluminum. So now this is what we are going for patent, design patent is there. Then second is, so we will say design patent. Then we will say all design parameters we will give in the .cat file. Then we will give the working functionally patent. Other people are using the spring. I am using the fiber bracketing sensor. Nobody has used. This is my patent. So all the claim I have to write, and then we have to send to Government of India. Fees is only 1,800 in Chennai office. But we have to write each and every steps we have to write, elaborate. So I will advise you some of the many places how to write the patent class. They will do the webinar. So attend the webinar and you will come to know where you should give the focus. So by attending the webinar, actually, you will definitely able to do it. No problem. So I have taken note of like webinar I have given for how to write technical paper for SCI, how to write the funded project proposal, then filing the patent, all those. So step one is the patent search. Just find out. Patent search, if you will give 5,000, they will find out and they will tell. After that, no 1 rupees also. Even patent search also without 5,000 also you can do by your own. Just check. Just check. It's like a plagiarism check. Nobody has done, you can file the patent. Any other question? I'm happy to interact
Thank
with
you, ma'am. Thanks a lot, ma'am. Thanks a lot.
Yes.
Oh, is any other query?
Yeah, very good afternoon, ma'am. I'm Dr. M. Sugasni from Tiruchirappalli, Tamil Nadu. Ma'am, small doubt. While we collecting the blood samples, you said no. Is there any data set other than Kaggle and government GOV data set? Is there any other repository is there?
Okay, fine. I understood. You are talking about artificial intelligence, right? Yeah. So,
Yes, ma'am.
okay, my one domain, yeah, I know. I told now 5, 6 domain I am working in my one group of people are working in AI also. Okay. So I'll tell you, which is totally different from my work, what I have done. I have done actual after MBBS, MD, they are doing PhD also. Some of the doctor, they are doing PhD degree also. So those who are doing the doctor, MBBS people, they are doing PhD means what? Means they have published the thesis, which is available in the sodhganga.com. There they have find out the refractive index of the blood sample for different disease, which I have taken. Okay, coming to your question, I will tell you. Recently, I have worked. I will show you everything. I have worked on the skin cancer. Okay, so in skin cancer, what I have done? Bhargav, type here Muskan. So in skin cancer, what you have done, ma'am? From the California repository, we have got all the skin cancer patches. 10,000 patches we got. For AI, the main difficulty is to find out the large number of data set. Data set means suppose skin cancer I am doing. So we have developed an app. So in that app, what happened? Because 10,000 skin cancer for the white skin we have done. That will not work for our black skin. It is for white skin, which was we got from the California repository, and we have trained our model for artificial intelligence. I don't know how much you can able to see that. You see here, this you can see the skin patches. I am showing you the in my mobile app we have developed. You can see. So what happened? Yeah, you see that they are showing. I am trying to show, and which I am going to put in the Google Play. This is an app now. This app you put we have trained our camera, mobile camera, and see. I don't know whether you are able to listen or not. So
yes, ma'am.
Okay, see, there's some skin patches are showing.
Ma'am, it is not visible. It's not showing.
I know. Okay. So just I will tell you orally. So what happened? We have taken the 10,000 skin patches for the cancer, for non-cancer, for malignant, for malignant, all the tissue, and we have trained our model. Then for cancer and non-cancer, we have taken skin patches for skin cancer. Then what happened? I am telling my own experience. So in my house, my mother-in-law was having some skin patches. So I took that photo. It looks like very dangerous, full some 3-dimensionally it came. So it looks like very like something happened. So we were having doubt. So that skin patches we have given. So we have trained our camera, mobile camera. Already we have done the program for our artificial intelligence by using artificial intelligence technology. So what happened? It will tell that any when skin patches we will show in the laptop, and when we will see with our mobile camera, it will show 98% it is skin cancer. When my mother-in-law skin patches I have shown, it has shown that 96% it is non-cancer. 96% it is non-cancer. That app I was showing you. Now, yeah, now what I'm trying to do, that app I am trying to put in the Google Play Store, so that more critic I will invite. They will write the, I do not agree, it's not working. With those critic, I will try to develop. The only problem which I am facing, that I want now for Indian skin. So when we will test with that app, we are not white. White skin means American or UK people, British. So our skin, it will not work, because the model which I have trained, it is taken from the white skin. This is the only problem in the AI domain who are working in AI to get the data set. It is really very, very tough. What is the answer? I have found out. I'm working with the Emirates University for the artificial intelligence. Very strongly we are working towards that. We have to MOU with the hospital. So I am trying to do with in Bangalore St. John Medical College. If we will get that MOU, then they will give. Because a lot of ethical clearance is there. Ethical clearance is the big headache, actually, I can say. When we are talking about ethical clearance, it is very, very difficult. Otherwise, we will not able to do any work in the biomedical healthcare. This is the main problem we are facing.
Okay, ma'am. Ma'am, thank you for your explanation. Well understood. Ma'am, one more doubt, ma'am. You have taken as a parameter as an image or the value from the data set. In California data set, image wise you have taken, or
image
value based?
All skin cancer images. No value. No value. I have taken the image.
So
Complete image
sentiment
I got.
analysis, have you used a sentiment analysis here?
Yes.
Okay. Thank you so much, ma'am. Thank you.
Thank you.
Thank you so much, ma'am. Now I request the participants kindly switch on your videos so that we can have a group photograph with the resource person, Dr. Preeta Shah. Ma'am, you can stop sharing your screen.
Stop sharing my screen. Yes, ma'am. Now and then stop
Yes,
sharing.
ma'am. Now it's visible for all.
Okay.
Participants are switching on their cameras. Just wait for a minute, please.
I'm really thankful that everybody was listening patiently. Starting level, some internet problem was there. Sometimes it happens.
But it was a wonderful session, ma'am.
Yes.
Thank you, ma'am. Thank you.
Thank you.
And for the participants,
can you get your contact details to contact in future?
Sure. I'm always ready, actually. So, ma'am can give.
Yes. I will share the
Can you write in
details,
the chat
ma'am's phone
box?
number and email ID with all of you in WhatsApp group as well.
Okay, ma'am. Thank you.
Sure.
Thank you.
I'm happy to collaborate with anyone.
Okay,
And
madam.
Like this only
she is very kind-hearted and always ready to help anytime. And I disturbed her a lot during this FDP, as well as our department is organizing one international conference, and she is helpful there also. Thank you so much, ma'am. You are so kind. And
it's
dear
all because of
participants,
all of you.
thank you so much, ma'am. Now I request the
Thank you,
participants they can leave, and we will meet at 2:30 at exact time 2:30. Thank you
Thank you.
so much.
Thank you, madam.
Thank
Thanks
you
so
so
much,
much.
ma'am.
Thank you.
Madam,
Thank
you so
Thank you.
much.
hello.
Thank
Attendance
you.
link is there, madam. Attendance any?
Sir, I have shared the attendance link in the chat box. Kindly check the chat box.
Chat box.
I have shared the link in the chat box.
Yes, ma'am. Thank you so much. Thank you.
Welcome, ma'am.
Thank you, ma'am.
Thank you. I'm resharing the link in the chat box. We will meet at 2:30. So, our today's resource person, Mr. Ajay Kumar from NITTR Chandigarh is with us. So I request Mr. Lakshmi Shankar kindly share the biography of Ajay Kumar sir.
Yes, good afternoon, dear all. Am I audible?
Yes, sir.
So I am reading the profile of Mr. Ajay Kumar Godra. Mr. Ajay Kumar Godra is the founder and director of Innovation Lab Chandigarh. He is innovator and mentor of Change Niti Aayog, Government of India. He has expertise in the area of robotics, Internet of Things, and artificial intelligence. He has developed many innovative products and having patent in renewable energy area. He has delivered more than 1,000 expert talks in national and international platform via contact mode and ICT based mode. He has trained more than 30,000 students till now. So I thank you, Mr. Godra, and I welcome you in this FTP. Mr. Ajay Godra, sir. Now over to you, sir.
Ajay sir, I have made you the presenter. Now you can share your screen. Sir, am I audible? Yes, sir. So can you switch on your video as well? Sir, you are not audible. I think you are mute. Not audible, sir. You are not audible, sir. Sir has some audio issues. He can join. He will join in 5 minutes.
We can talk over here also about the latest industrial trend that is in the future, that is just in the talk, that is industry 5.0, that is fifth industrial revolutions. So when we talk about past industrial revolutions, so we can interlink their importance and their job capability and uh, job can be created using industry 4.0. So these are three industrial revolutions that happened in the past. The first one is hydropower and fossil fuel, that was in the 18s, and then after that electrical energy and mass productions. So mass production concept came in the industrial revolution, that is second industrial revolutions. Now, when we talk about third industrial revolution in the past, that was telecommunication and PLC. So that you can see over here, that is known as automation over there. So now we are living in the era of fourth industrial revolutions, that is industry 4.0. So industry 4.0, when we talk about it, so over there you can see these are important concepts, those are going on in the industry. So that will go 1 and 2 more years in the industry, and when we talk about industrial revolution in the India, so India is a little bit behind the current industrial trend. So still we are using industry 4.0, and that is not fully implemented till now in the industries. So that is the trend is going on in the industry also. So over there, when we talk about key factor of industry 4.0, that is about factory become digital and flexible. So how we can make factory digital and flexible? So IoT is going to play a very important role over there. Then after that, simulation tool and powerful data processing. So over there also, when we talk about simulation, so now in these days when we talk about learning IoT, over there also a lot of simulation tool is being going to play a role over there. And when we talk about IoT simulation for industry 4.0, or when we talk about building factory smart and digital, over there also we are going to use some simulation tool. With the help of that, without having any kind of hardware, we can visualize it, we can virtually simulate it also. So the third one is over here, that is key principle over there, that is an efficient factory regarding energy and resources. So in current scenario, when we talk about industrial productions, industrial products, so when we talk about manufacturing sector over there also, continuously material price is continuously increasing. So the industry is having a major challenge that they have to reduce cost, and they have to compete in a global market also. When we talk about globalization, that is also all over in India, and when we are going to manufacture anything, we have to compete in a global level. When we talk about automobiles, over there also you can see many automobile manufacturers are in the market. Those are from other countries. So in the country, in the India, if we are going to manufacture any product and we are going to sell it, so we have to compete it in a global market also. So there is a big challenge for the industrialists that they have to reduce the cost and they have to maintain the quality also. So when we have to maintain both things, so what can be done? How we can meet that challenge? For that, they have to utilize all the resources in an optimum way so that they can reduce the cost. They have to use maximum simulation tool so that they can reduce the product cycle cost. So when we are going to manufacture any product, we have to check it out at the end, and we have to perform certain test over there. So during that test, we have to do some a practical test. So over there is lot of failure, there is lot of redesigning of that particular part at that time. So at that time, that is creating a problem. So now we are going to meet those challenges using Industry 4.0, that is fourth industrial revolutions. So let's see over here that how we can meet those challenges. So these are three things, three key principles that I have discussed over there right now. Now we are moving ahead. Yeah, thank you so much. If you face any difficulty while watching this session, you can respond in the chat box also. That would be very important. So yeah, now we are moving ahead. So these are major component of Industry 4.0. So when we talk about a major component over there, you can see like digital technology. These are buzzword of today's scenarios. Might be you have heard about all these buzzwords like robotics, AI, artificial intelligence, and sensors, big data, 3D printing, software as a services. And over there, when we talk about IoT, that is Internet of Things, that is one of the major component over there that you can see it. So in IoT, when we talk about, just see this animation over there, you can see a robot that is fully smart robot, and that is autonomous robot, and that is being controlled by AI, and sensor is being get deployed over there for sensing the surface over there, and all the data is being sent on the cloud. So the robotics is also there, AI is also there, sensor is also there, 3D printing is also there, because all the part is being get printed using 3D printer. So after integration, all these things, data is going on the cloud, and the complete product is being used for the industrial automation. Same way, in the industry, machine is being got fully smart and digital. So when we talk about automation, automation means fully smart and digital things that can be easily operated, and that can be sportive for the human being also. When we talk about industry 5.0, what is the difference over there in industry 4.0 and industry 5.0? So in industry 4.0, we are facing some challenge. What are the challenge? Challenge is that we are building very smart machine, and all the machines are connected with the cloud, and machines are being get so much intelligence over there, artificial intelligence. Now the challenge is over here is that we have to interface with the human being. When any human being is being get interfaced over there, so there is a lot of challenges occurring. So in industry 5.0, the process, same industry 4.0 technology is over there, but we have to integrate it with the human being. So that add-on is part is coming in industry 5.0. That is the future technology, future industrial revolutions. So over there, when we talk about IoT ecosystem, that is Internet of Things ecosystem. So over there, you can just visualize that in upcoming 5 to 7 years, you will find that automation. That is the example of industry 5.0. Mean human being a friendly technology. So I mean automation with the human friendly, mean that there should not be any harm for a human being. So that can be integrated with a human being. That is the real that is the example of industry 5.0. Same way in industry 4.0 also mean making things fully automatic, making machine fully smart. That can be helpful for the society and for the industrialist also, of course. So now over there you can see, as you're going to wake up from your bed and you are going to get dressed fully automatic, and after that, as you're going to wear your suit, your car will come automatically in front of your door from the parking. So now in these days might be have heard about like automatic car parking in some expensive cars like Mercedes, Audis and BMW. So in upcoming days, you will find fully automatic car, and the car will come automatically in front of your door from the parking. And as you are going to wear your suit, over there sensor is being get mounted, and those sensor will send signal to your car. That is just animation to represent industrial automations. So what exactly is Internet of Things when we talk about it? So that is the integrated part. Like when we are going to understand any industrial automation using IoT, so we should know what is IoT. Then we can start understanding about IoT. In IoT, one of the major thing is that maximum time we are just going to misunderstood IoT. We are just going to club IoT to computer science discipline only. But when we talk about IoT, it's a multidisciplinary approach we have to use over there when we are going to deploy IoT solution over there. And now when we talk about the companies, those are going to deploy IoT solution, those are MNC companies like ABB and many more companies like IBM. Those are going to deploy IoT solution in the industry. that we are going to call industrial internet of things. So over there you can see sensor and actuator, connectivity, people and process. So these are three major components. Those are being used to those are being used for IoT integrations. So when we are going to build any IoT solutions, over there we have to work on the sensor and actuator first component, and the second one is the connectivity, that how we are going to connect those sensors with internet. Then third one is over there that you can see people and process. It means what application you are going to perform, what you want to do with the sensor data. Is that useful for your some applications? So that is being come up in the process, in the people and process. That is third one component. So these are sensor and actuators. So when we talk about first component, we are going to elaborate it over here. When we talk about sensors, it means there are many sensors. Like we can just take an example of human being. So we are having different sense. So similar way we have to give sense to the machine. We have to make intelligent to the machine using some sensors. So those sensors understanding is very important, that which one sensor we can use it for what applications. So like we are going to talk about like we are going to build some surveillance drone. Just take an example of surveillance drone. So in the drone, what we have to do it over there, we have to mount some vision sensor over there, some camera sensor over there, and sometime we have to mount over there some thermal camera also for analyzing that what we want to do surveillance over there. So like when we talk about agriculture surveillance drone, so over there we have to identify the crop and their health also we can identify using thermal camera, and we have to use some sensor over there for altitude and then GPS location also over there. So that is one application that I have just discussed. So that is upcoming scope of that drone technology in the future, because a lot of guideline is being prepared by Government of India in a drone technology. So that also going to get integrated with the society also. Then after that, when we talk about different sensor and their usability, so few application that I'm going to elaborate over there, and many application can be built it over there using these sensors. Those are commonly used sensors. Like when we talk about machine vision and ambient light sensor. So for that you can use camera. Camera is one of the sensor for identifying anything, for monitoring anything, for any kind of machine vision. I mean, when we want to see that we want to build some machine that machine can see, so we have to use camera over there that is working as a vision sensor. Then after that, acceleration and tilt sensor over there. So this one you can see it over here. So when we talk about acceleration and tilt sensor, so over there we have to use that acceleration sensor that is being used in a mobile phone also, and that you will find in many other applications also. Then electrical and magnetic sensor, with the help of that you can detect directions. So if you have to identify any direction, that can be identified using that electrical and magnetic sensor. So with the help of that you can do it. So then after that, leak and level sensor, with the help of that you can get leakage. If there is any kind of leakage, you can detect it, you can diagnose it, and you can utilize for some application also. Like when we talk about any petroleum industry over there, if there is any kind of leakage over there, so that can be identified and any kind of losses can be avoided over there. When we talk about any LPG transmission lines, so in few cities that is being get integrated in the India also, like LPG is being distributed using pipelines, that rather than you are putting cylinder at your kitchen, so you are going to get LPG supply a similar way to the water you are getting at your home. So over there these kind of sensor are going to play very important role. If there is any kind of LPG leakage, that can be identified easily and can be diagnosed easily over there. So that can be done over there. So now we are going to talk over there about these kind of sensor. Then after that you can come up with the load sensor also. So load sensor is also over there that can be used for identification of any kind of loading applications. Just take an example of you are having LPG cylinder at your home and you want to know that when that cylinder is going to get empty. So for that you can deploy that load sensor over there and you can integrate using IoT with your mobile phone. If your cylinder is going to get empty before 1 week, you will get some warning, some alert on your mobile phone that yes, your LPG cylinder is going to get empty after 5 days, 6 days. So you can take some preventive action over there. I mean, you can do booking of that LPG cylinder and whatever you want that can be done over there. So now similar way over there you can see a few more application of load and force sensors. So those are being used in a mechanical and civil application also. Sometime when we are building some mechanical and civil application, over there also that can be used. So then after that flow sensor, with the help of that you can measure any kind of flow, like one of application of that flow sensor is that is being used in a petrol pump. So when you are going to petrol pump over there, that nozzle over there, the meter is being attached. So with the help of that you can identify the flow, that how much liter is being petrol is being get filled over there in your vehicle tank. So that can also be identified using that. Now similar way the chemical and gas. So those sensors also can be used for detection of any kind of gas leakage. So that gas leakage can be detected using the sensor and you will get notification also over there that you can deploy it on your kitchen also. That can be deployed in any kind of industry over there. Gas is being extracted or produced or being used over there. Then after that acoustic, sound and vibration sensor. Those are also very important. So like if you are going to acquire some brain signals, some ECG signals, those signal can also be extracted and can be used for some specific applications. So that can also be used over there. Then after that you can see humidity and soil and moisture sensor. So those sensors are also can be used for detection of any kind of humidity, moisture, water content over there. Some air quality also can be measured using that. For environmental application, we can use these kind of sensors. Then temperature sensor also can be used for environmental application and some industrial application also over there also you can use this one. So after that some motion, velocity and displacement sensor. Those are being used in vehicles also or in some different rotary part machines over there also can be used. Then after that position, presence and proximity sensor. This sensor is being used in home automations and in some hotel, restaurants and some in malls. Over there this proximity sensor is being used for some automation over there. So that can be used. So these are commonly used sensor and actuators. So you can build many applications using those sensors. So and those applications can be innovative also. You can go for the patent also using those applications because those are new trend in the market. I mean, if you're going to build something new using those sensors, that can be helpful for the society also, and that can be a new technology also. So that can be developed. Because till now when we talk about society over there, the traditional things is being get done like specific disciplinary things, but that IoT is multidisciplinary things. If you are familiar with the sensor and you can build some IoT application in a civil engineering, so that can be get patented. That can be a technology. You might be a computer science engineer or you might be a electronics engineer. It's not important, but important is technology that you are going to build it. So now after integration of these sensors and actuators, you can come up with the connectivity that how you are going to acquire those sensor data, and after acquiring those sensor data, how you are going to send those sensor data to the cloud. So which mode of connectivity you are going to use it, that is very important. So when we talk about connectivity or networking, so how you are going to network those sensors with the cloud, with the internet, so these are different mode of connectivities. So and very important point, one more thing over here in a sensors, now in these days some sensors are coming, those are being based on free energy. Free energy means those sensor will not consume any amount of energy. So those sensor you can deploy it in anywhere in any location and you can get their sensor data. So that can be used in industrial application also, and that can be used for controlling any appliance also in a long range. So those are very trending topic in today's scenarios when we talk about IoT and Industry 4.0, mean energy less sensors and actuators. So now we are going to talk about connectivity. So connectivity is very important, that how you are going to acquire sensor data, how much energy you are going to consume to acquire that sensor data. So over there what you are going to do it, you are going to use different mode of connectivity. So which mode is best for what application? So when we are going to design and going to develop IoT applications, so you have to build your devices that can be based on low energy device. So your sensor is also based on low energy, so it should consume minimum energy, and whatever mode of communication that you are going to use it, that should be also based on low energy. So over there, these are different mode of technology that can be used for IoT applications. So first one is over here, like that barcode that can be QR code that can be used over there. So that QR code can be used for that particular application for acquiring some small data. The data, some information we can acquire it using QR code. So that, like now in this day, that data we are using it for online payments, like Google Pay and different phone pay payments. We are doing it using that QR code. So that code we are scanning it on the petrol pump or in the grocery shop and all that, and we are acquiring that data. All the data and their UPI ID is being acquired using that QR code. That is one mode of data transmissions. So the distance is very less over there in between that QR code and the device of acquiring data from QR code. So then after that, when we talk about long range, we can use Bluetooth also. So in a Bluetooth, that is can be used in a limited range of up to 10 meters. So up to 10 meters we can use Bluetooth, and when we have to go beyond that range, we have to use different mode of connectivity. So one is Bluetooth, and Bluetooth is also being used in a low energy. So Bluetooth is being used when we have to send more data and with small distance. So in a Bluetooth we can do that. We are using Bluetooth speakers also for voice transmission and all that, and Bluetooth earbuds also we are using it. So these are different mode of data transmission that can be used. Then after that, Wi-Fi is being used for long range, like up to 100 meters without internet. I'm just talking about on the local network without internet. We can transmit data up to 100 meters. So from 10 meter to 100 meter, and high data rate also we can transfer using Wi-Fi. So that is one mode. Then after that, we can use that LTE also, like cellular network we can use for data transmission. And out of that, over there, that one important point is that recently I have discussed about free energy sensors. So for that we cannot use Bluetooth. Sometime we are using Bluetooth, but that is not recommended. Then sometime we are using Wi-Fi. That is also not recommended, because Wi-Fi is being required more power to transmit data. And sometimes we are using GPS also and GPRS data also, that also consume more data. And for that we are using LPC, we are using LoRaWAN, ZigBee. So these are when we talk about LoRaWAN, it stands for long range wide area network. So in a LoRaWAN, what we are going to do it, we are able to transmit less data with a high range. So less data with a high range. Okay, so when we talk about NFC, so NFC is similar to when we talk about NFC. So NFC is similar to RFID. So RFID tag is being used in a toll plaza. Might be you've heard about that tag that is being used in a toll plaza. So that is mandatory now in these days for everyone. So that RFID tag is being deployed on that vehicle, and we can acquire that information when the vehicle is passing on that toll plaza. So automatically their toll is being struck from their bank account. That is one example of IoT, real-time example of IoT. Similar way, RFID, the NFC is being used. NFC is a card that is similar to ATM card, and that NFC is being used in a metro also. Might be you heard about metro card. So metro card we are using it. So that is based on NFC. So the range of that NFC is also very less. You have to bring your card closer to that NFC. That is also coming in a mobile phone also, that NFC capabilities, and few ATM is having that capability of NFC also. So that NFC is being used for small information and secure information we can carry, and we can process data very fast. So similar way, that antenna is being used for that same way. When we talk about LoRaWAN and LoRaPAN, both are similar things. So LoRaWAN that I have discussed over there, that is a low energy and long range wide area network. So when we talk about long range, so we can send very small amount of data, but the range of that data we can transmit, that is very high. Up to 100 kilometer we can send and receive data without internet, without mobile network. So in a remote location, if we want to send data and we want to receive data, and very important point is that this mode of communication consume very less energy. So the free switches, that actuator and sensor, when we have to use it, free energy based, so we have to use that LoRaWAN technology. So in a LoRaWAN, over there we can send and receive data with the very small energy, small amount of energy, and that data we can send it from the long range also. So when we talk about IoT, in IoT we are going to use very small data over there. We are not going to do video streaming using IoT, because in IoT we need a sensor data in a binary logics. So sometimes we have to get data in a binary logic and small, in very small bits and bytes, maximum byte kind of data we have to receive it over there. And the data is very important for us. That data frequency is also important, that how much interval, after how much interval we receive to that data, that depend upon the application. So now over there, so the technology is latest that is going on, that is LoRaWAN. So now after that, Bluetooth, Wi-Fi, all these things that we have discussed, and using that we can perform IoT applications. So now these are different mode of sending data over there, like WAN, wide area network, MAN. These are different mode of communication that is being used for networking applications. Now these are applications. I mean, we have used sensor, we have acquired sensor data. After acquiring that sensor data, what we have to do, we have to perform some applications. So what application we want to perform, that is very important over there. So we are going to perform application over there, like you can see over here, remote monitoring and maintenance. If we are going to do any kind of maintenance over there, so that can also be done using IoT. And if we want to upgrade and configure machine, so that also can be done using IoT, using the data, whatever data we have acquired earlier. You can do some analytics also with the data. And that analytics, you can use it for some applications. So what kind of analytics you can do it? So one example that I'm just sharing with you. The one example is over here, like Ola and Uber. So that Ola and Uber, you are using it, and similar way like some foods delivery services also like Zomato and Swiggy. So they are also using that IoT platform. So what they are doing, they are acquiring mobile data of customer and the that delivery boy. So the mobile data is being sent on the cloud, and when we are going to do any kind of food order, so what is happening over there, they will find the nearest delivery boy and they will send your information to that delivery boy. But after sending that information over there, they are also going to do some analytics over there, that how much time it will take to prepare that food and how much time it will take to deliver that food. If after picking that food, you will able to see real time monitoring also, and after picking that food, they will let you know also that how much time it will take to deliver you. So that also you can get it over there. In similar way, that is being used over there in Ola and Uber also, when we are going to do any kind of booking over there. So over there also we can use the same way. So they will let you know with the drive, that platform will let driver to know that which one is the shortest path that driver has to follow. So now the same way, you can do some location tracking also. Like if you are going to track any vehicles, that also you can do it. And if you want to do some control, that control and automation also can be done using that IoT. So after that, when we talk about some mobile devices and application, if we want to visualize that data in a mobile app, that also can be done using that IoT. So that also can be done, and that can also be built on the cloud platform. So after using three things like sensor, connectivity, people and process, we can build some more application over there. Some more good application can also be built over there, so that you can see over here few of the applications that can be used for that app, some IoT applications. So now over there you can see when we are going to talk about smart thermostat, meaning we want to control the temperature of home automation. So over there you can use some application. Connected cars, activity trackers, means the bands we are using in our hands for health monitoring, those are trending in these days. So smart outlet, so over there also it is being used. So then after that, some parking sensors. So in parking sensor also can be used over there. Like if you are going to park your vehicles, so you can integrate it with the mobile app, and you can park your vehicles as per availability of the parking. That also you can check it out. So then these are few applications. Now these are diverse applications, that these are the domains over there IoT can be used. Those are not limited. So these are few applications that I shared over here with the specific domain that you can see it over here. So over there you can see home consumers. So when we talk about home and consumers, so over there you can see like light bulb, security. These are different applications for that you can use IoT over there. Then after that you can see over here some more like transport and mobilities over there also you can use it. And then after that you can go further also. These are few more applications in a health and body also, like those are in upcoming trend. So in upcoming future, when we talk about the scope, so in healthcare also there is a huge scope of IoT. Then after that building and infrastructures, so that also you can see it over here. Then cities and industries also over there also you can use it. So in a cities like smart city, electrical distribution, maintenance, surveillance, signage, utilities, smart grid, emergency services, and in building infrastructure also over there also IoT can be used. So now when we talk about civil applications, so IoT can be used in building and infrastructure also. So there is also huge scope over there. So some more compound application over there like transportation plus smart cities, both can be integrated also. So there is also diverse application of IoT like smart building plus mobilities that you can see it over here. So that you can see it over here. So some real-time services and networks, some more application in like yes, in cattle farming also, like dairy farming that is so much popular in the India. Over there also that IoT can be integrated, like their health monitoring can also be done. At which time that your animal is not feeling well. So over there also you can integrate IoT. So their health also you can monitor, and at what time that water is being required for that particular animal. So their that heart rate also you can identify with the heart rate data. You can analyze it. You can put some analytics over there, and if you want to increase their milk production, so if you are going to provide proper environment, proper feed, so definitely you can improve their productivity. So sometime what is happening, some disease attack is being occurred on the animals, but we are not able to identify it. One that disease is being become dangerous for the animal, then we are able to identify it. So then we become too late. So early detection of any disease can also be done using IoT, and everything can be monitored using sensors. So how large is IoT market? So that data is for 2014. So over there you can see 2 billion connected devices were shipped for IoT application in 2020 or 2021. More than 8 billion connected devices is now in these days. So when we talk about this data is up to 2020, because in 2021 there is no specific data due to COVID-19. So over there you can see that the scope is growing exponentially over there. So that you can see it over there. So now over there you can see the growth. So when we talk about 2020 or 2021, over there the market when we talk about that is more than 1 trillion globally. So these are some IoT applications over there. When we talk about manufacturing, smart city, home automation, logistics, smart building, energy, environment, and agriculture. So when we talk about automobile over there, the value chain of industry 4.0 and IoT integration over there, that you can visualize over here. Just see it over here, that how IoT is being integrated over there in that specific application. So over there you can see that when we are going to manufacture any product, so over there we are going to manufacture in a batch size, mean different part in a mass production we are manufacturing it. So over there you can see like 3D printing we are going to do, and all the data of each part is going on the cloud. That is showing the Wi-Fi. So that is connected with the internet, and all the data and all the algorithm is being integrated on the cloud. So that is going on in the industry. So you can see the industrial robotics and IoT integrations. So that robotics is being integrated with a IoT also over there. So over there you can see the cycle time and the manufacturing cycle over there in the industries. So in this cycle you can see in 1 minute one vehicle is being manufactured over there, that you can see it. So you can see in one cycle time one vehicle is coming out. So the fully automation is over there, robotics is being integrated over there, and all the data is going on the cloud. So there is only few workers you will find it over there. They are just monitoring the things, and all other thing is being monitored from the cloud and from their control room, that you can see it over there. So now over there you can see so over there, a very important point is that all the data is going on the cloud, and if there is any kind of failure, that can also be diagnosed early, so that can be done over there. So using IoT. So all the sensors data is going on the cloud, and in 1 minute, one product is coming out that you can see it after assembling it. This one is not fully manufactured in a 1 minute, but after assembling, one product is coming out. So that is automation. Similar way, few industry is being using that automation. Like when we talk about Maruti Suzuki, they have recently installed one plant in Dharuheda, and similar plant is being get installed in Gujarat also. So they are also integrating fully automation over there in the plant. So AI also in upcoming days, you will find those kind of robot for different applications. Those are highly demanded in this COVID era for serving patient. So this kind of smart robot is also required for fighting some disease or some epidemic over there. So as we are going to enter in a 5G, so 5G can also be get launched in India soon. So after 5G, you can just visualize the scope of IoT. Might be that is new buzzword for you in if you are not familiar with the IoT, but just visualize the future of IoT. So earlier we were in a 3G and 4G, and you can see over there limited devices were connected over there. But as we are going to enter in a 5G, you can see over here more devices is being get connected. Cars also get connected with the mobile phones, and your cloth also get connected with your mobile app, and they will let you know that when your cloth has to be washed. So they will let you know. So I mean everything is being get connected with your mobile phone. So that is important. So in upcoming days, you can just visualize that everywhere IoT you will find it. Now you are just listening that yes, IoT, 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 but in upcoming days you will find in your day-to-day life also. Like you are using your health band, IoT is also over there. You are using Ola and Uber, you are using any food delivery services. So over there also you are finding IoT. So why should not you acquire that skill set that how you have to deploy IoT solutions? So that can be very helpful for the students when they are going in the industry and they are going for the interview for any kind of placement activities. So there are some disadvantages also that we have discussed. Now in these days, few challenges is being occurred in industry 4.0. That's why we are entering in a industry 5.0. Mean human being intervention over there. So that should be fully safe for the human being intervention. That is being get discussed over there. So you will find in upcoming days home application robots also. So all the home activity is being done by a robot. But that love and affection is very important in between human beings that cannot be taken by robots. Yes, the one sometimes we are designing some automation application, but if that there is some failure, faulty and not precise, so we will not get exact result that is desirable. Yes. So this one is just for entertainment, that is visualizing over here that how boss is behaving when a student are not familiar with the latest technology that is going on in the industry. So if there is any kind of failure in their machines due to lack of knowledge, so there is a huge loss for the industry, and boss will behave like that you can just visualize it. Yes, so every component over there in industry is important when we are going to use industrial IoT over there. So every component is important, like capacitor. Just take an example of a capacitor. So over there in a capacitor, if that capacitor is being used in a reverse polarity, so you can just visualize that capacitor get blasted over there, that you can see it. So very important point is that how you are going to use the component for some application, if that capacitor is being used in an aeroplane, what can be happened over there? How much casualty can take place over there? Just visualize it. If that capacitor is being used over there in a reverse polarity, so all the component like resistance, those are when we are going to start IoT, you should know the basic component like resistance, capacitor, LEDs, how we have to use them. That is very important. These are color code. This one is a LED, how we can use LED for that applications. Like you can see which one is a positive, which one is a negative. Then you can see over here, this one is a process in industry. When we talk about IoT uses in industry, just take an example of any manufacturing industry. So in a manufacturing industry, over there you can see this one is a manual process. That is simple example of a boiler that is being used in a maximum manufacturing industries. So over there in a boiler, you can see that process of controlling of temperature and pressure of that boiler is being carried out using that specific manual valve with the operators. Sometimes there is a chances that that operator can go for a sleep, because that is human being, that is the chances over there. If that operator can go for a sleep and that boiler cross the threshold limit of temperature and pressure, what can be happened over there? That boiler get bursted and more than 1,000 casualty took place over there. Why it is so? Because recently 3 and 4 years before, that incident took place in a UP, in Uttar Pradesh, in a NTPC power plant. So that's why the boiler is very sensitive component over there. So if that process we are doing it manually, so there is a lot of risk. So that we have to take care. So that's why IoT is required over there. So IoT is being get integrated over there, so we can avoid any kind of risk over there. So sometimes boss is Persian, so worker is working like this. I'm not against with the work culture. I'm just showing some realities over there that is happening. So now you can see it over here. These are different microcontroller and microprocessor we can use for IoT application. Might be familiar with all these microcontroller and microprocessors. So these are commonly used microcontroller and microprocessor for IoT application, for learning applications. Like when we talk about institution, over there we are going to start beginning with the IoT. You can go with these components like Raspberry Pi, and one is Arduino Uno, that you can see it over here. So Arduino Uno and Raspberry Pi. So this one is a Raspberry Pi and this one is a Arduino Uno. So there is a lot of low cost Arduino also that can also be used when we are going to start building any kind of IoT applications, that can also be used over there. Now over there you can see Raspberry Pi also, that is also coming in a low cost version also, that I will let you know later on. So that can also be used. So now we are going to talk about Arduino. So quickly we will discuss about basic Arduino things, that how we can use Arduino and which tool you can use it for learning Arduino freely without having any kind of hardware also. So over there, this one is Arduino Uno, that you can see it over there. These are input output pins. Those are digital input output pins, and over there you can find some analog pins, and these are power pins over there. This one is a microcontroller that is being used over there, that is 8 mega 328P. That is a microcontroller, that is 28 pins microcontroller. So that is being used over there in this board, and you can use this microcontroller separately also and with this board also. That is for learning purpose. When we have to deploy this board in some product, so we can use directly this microcontroller. And the cost of this Arduino Uno is approximate 400 to 500 rupees. That is Arduino clone. Clone mean when we are going to talk about Arduino is being made in Italy. So when we are going to purchase that Arduino made in Italy, so that Arduino is coming from the Italy for you, and that cost approximate 2200 to 2300 rupees. So you can use clone also, because some companies those are making it in India or in the China, so those are very cost effective, so they can also use it, and working will be same. There will be very small difference over there in the working. And when we are going to use this microcontroller only, so what you can do it, this one is a Arduino Uno development board. So over there you can program it using USB, and you can remove this board and you can deploy it directly also in the product also. If you want to use this complete board, that also you can use it over there. That is up to you. That is external power. That power you can give to this board when we have to deploy it over there in your product. So this one is a reset button, and that you can use it when you have to restart that board. So this one is a tool that you can use it for starting Arduino from the beginning. So what is the name of the tool? That is Tinkercad. Might be you are familiar about it, the Tinkercad. So you can open this Tinkercad. So if you are familiar with the Tinkercad, you can give your response in the chat box yes and no. If you are familiar with the Tinkercad, you can give your response in the chat box yes. Otherwise, you can type no in the chat box. Accordingly, I will discuss in detail. If you are familiar about it, I will not let you know about the basic steps over there. I will quickly skip it and I will go ahead directly. Okay, so so few participant response, I got it over here, that is no, and some participant response is yes, that's great. Yes. So when we talk about this tool, that is Tinkercad, first of all, this one is open source, free of cost, free of use. No need to pay anything over there. And if you are beginner in the Arduino, then also you can start working over there. So when you are going to use it first time, you have to go to the Google, and over there you have to search Tinkercad directly. So I'm just going to search on the Chrome browser Tinkercad on the Google. So over there you will find this link, Tinkercad from mind to design in a minute. So over there you have to open it, and after opening this, we are moving ahead. So after doing this, there is an option of join now. So you have to click on the join now, and you will find these options. So you have to go with third one option, create a personal account. So educators start here, and you no need to click right now. That is for school or college when we are going to create a classroom and all that, so that you can do it later on. You can click on create personal account. So over there, these are options. You can go with sign up with an email, and you can go with sign up with the Google also. If you have, if you are using already your Gmail account, so you can go with this one also. So now I'm going to use it with the sign up with the Google. Then it will ask about that if you're having multiple account login, it will ask about account, that which one you are going to use it, and you have to select it. And after that, within 3 steps, you will be able to do sign in directly. So that is very easy step to do sign in over there. And after that, you will find this option over there. So on the left hand side, you will find circuit. You will find circuit over there, that you can see it, circuit. In the circuit, you have to click it. And after clicking on the circuit, you will find create new circuit. You will not find this circuit. Those are previously saved circuit. So that I just made over here. So you have to click on create new circuit, that you can see it. After clicking over there, your circuit will be get open. This one is online. So if you want to use it offline, you cannot use it. You have to use it in online mode. You can use it in a mobile phone also. If you are not having a computer and all that, you can use it in the mobile phone also. So these are the components. You will find it over there. That component can be seen like this. So over there, what can be done? You have to just drag and drop, and you can make your any circuit just simple way. I'm just showing you over here this LED. I'm going to drag it, drop it. So you can use this tool for fit to screen. And then after that, if you want to take battery, you can take this battery, drag and drop, and use fit to screen. So this one is a 9-volt battery. So how you have to make a connections, I mean how you have to connect wire over there. For connecting wires, what you have to do it over there, you have to take these terminals. So as you are going to take your mouse cursor over there in the components, you can see anode, cathode. These are the terminals. So anode is a positive, cathode is a negative. So anode, I'm going to connect it. So click over there, wire will be get ready and join. Same way, click over there and wire will be get started. Click if you want to make any turn, then again click. So the wire is being get connected. Now you can start simulation. So as I'm going to start simulation, you can see LED get damaged. Why it is so? You can take your mouse cursor on the LED like this, and now it will show that current through the LED is, that is 915 milliampere, while absolute maximum is required, that is 20 milliampere. So mean high current is flowing through the LED. So what we have to do it, you can give your response in the chat box. What is required to reduce the current? What component we have to edit over here? You can mention name of the component in the chat box. What component is required to reduce the current flow in the circuit? Yes, resistance. Yes. So if you want to mention resistance value, that also you can mention over here. So I'm going to use one resistance over there. Yes, if you want to mention the resistance value also, that also you can mention over here in the chat box. Okay, so I'm going to connect resistance over there. So you can connect in any side, in a positive side or negative side, that is not an issue. So I connected resistance over there. So what I'm going to do, click on the resistance, you can change the value also. I'm going to make it ohm. So I just put it 1 ohm and let's see what is happening. So still LED get damaged. Why it is so? You can see the current flow through the LED is 808 milliampere, but required is 20 milliampere. So what we have to do, we have to increase that resistance value. So I'm going to make it 250. Then still it is showing warning. What is the warning? Warning, it is showing that still current is flowing, that is 27.3 milliampere, but desirable is 20 milliampere. So it shows that life of that LED will get reduced. So if you are using in this condition, so what we have to do, you have to use proper resistance. So that I'm going to use it over here, that you can see. So now my LED is working fine. So everything you can check it out over there in the Tinkercad. So you can save this circuit also, like I'm going to rename it LED test and click over there again, and your circuit will get renamed. So if you are going to make new circuit, so what next you have to do it over there. If you are going to build a new circuit, you have to go to home. This Tinkercad is a home option over there. So you will find your circuit over there. You can open it again. So now when we talk about microcontroller programming, if you're not familiar with the C programming, embedded C programming, so how you can do it over here, the coding part, that also I'm just sharing with you that how you can do easily coding. So I'm going to start new project because this one is already being get saved. So click on the create new project, create new circuit, and that circuit is being get opened over there. So now over here, I'm going to use microcontroller. So this one is a Arduino Uno. You can take it and you can connect over here. So now what I'm going to do, I'm going to connect this Arduino with LED. So I'm just going to make automatic LED blinking. Make it connect it. So I connected with 30 number pin. So now you can write code. So by default, you will find code for 30 number LED. That is a graphical coding. And if you want to write in a C coding, so that is embedded C coding. That will generate it automatically when you are going to do graphical coding. You can delete it. So these are the blocks you have to use it for graphical coding. That is also very easy to understand. So now over here, what I'm going to do it, I'm going to take those output, take that second block. You can see automatically embedded C code is generating. So now what I'm going to do it, I'm going to select pin number 13. 13 number is high. Then after that, you have to go to control and you have to use wait, delay for 1 second. Then again, same block you have to use it, go to the output. So how you can came to know that which one block you have to use it? For that you need some practice, that from where which one block we can get it, because right now we are having a limited time. I cannot explain each and everything in a detail in a limited time. So for you all participants, we are going to launch one new course for 1 week of advanced IoT. Over there we are going to discuss all these things in a detail. That course we are going to start at end of the November, so in the last week. So that for that, if you want any information, you can WhatsApp me. I will share with you my WhatsApp number also. Yes, so you can make it low. So this one is a complete loop that you can see it for LED high, LED low for 1 second. And this one is embedded C code that is generated automatically. So what now we have to do it, we have to start simulation. So LED will start blinking with the interval of 1 second on and 1 second off, that you can see it. And now if we want to change the timing, just change the delay of 0.3. If you want to increase that blinking interval, if you want to reduce the blinking interval, so that I'm going to do it. Now LED will start blinking fast. So similar way you can make many more projects. So like few of case studies I'm just sharing with you that you can make it over there easily. So that I'm going to share with you. So let me share with you some more projects so that can be built it over there. Some interesting project also you can make it. Like if you are going to make social distancing gadget, and if you are going to make a piano, that is very interesting project I used to share. Like if you want to make a piano, because sometimes students are not familiar with the new concept. So if they are going to attach with the music, if they are familiar with the music, they will enjoy it. So I'm going to make it over here a piano. So that piano we are going to run it over here, and we can play a sargam over there like sa, re, ga, ma, pa, dha, ni, sa. So let's try to play over here. So I'm going to start it. If you are able to recognize that voice, you can give thumbs up over here in the chat box, or you can type yes over there in the chat box. I'm not too much familiar with the music, so I'm not able to play any kind of music over there. If anyone is familiar with that music, they can play any song also over there. So those kind of interesting thing can also be made without having any kind of component. That is just beginning of a IoT. And after integrating, after getting familiar with the basic of sensor data acquiring with a microcontroller, you can use some Wi-Fi devices, you can use some hardware also, and you can send data to the cloud, and you can perform some application on the cloud also. So some open source cloud also I'm just going to share over here so that you can get familiar about it. So few case studies that I'm just quickly sharing with you so that you can just visualize that how few application of IoT is being made over there. So over there few projects that I'm directly going to open. Those are based on LoRaWAN, that is weather monitoring station based on drone. So that you can see that we have developed at NATO campus over there in the Chandigarh. So that is the location, and the location also you can track it simultaneously if you are moving your drone, and you are able to see the weather report from different location in nearby area within 10-kilometer range. So then similar way, one more project over here that you can see it. That is the emergency rescue system in a lift that we have designed over there with one of the ME student in the NITA campus. Then after that smart energy meter also that you can make it, because in upcoming days might be heard about few news about the smart energy meter that is being deployed. So that is based on IoT using LoRaWAN. So up to 50 kilometers, the data is being transmitted automatically without having mobile network using that IoT. So that you can able to see it. So these are few case studies that I have discussed over here. So this one is also open source. So whatever I shared with you that is being used for education application, those are free, those are open source, so that you can take care about that. So now that few things that can be made over there. So few more case studies over there when we talk about industrial application, like this one is a condition monitoring of a machines. So if you want to control any motor speed, so that also you can control it over there. You can monitor motor health also using voltage, temperature, current. So all these parameters you can monitor of that particular specific motor. So there is many more project over there that can you can make it over there using Wi-Fi module, using LoRaWAN. So you can use Raspberry Pi also over there for integrating it with all the data. You can monitor of the Raspberry Pi. Real-time data can be monitored, and their GPIO pins also you can use it over here, that you can see it. So you can use that ESP8266 module also, that that is also very low cost module. With the help of that also you can send data over there. So these are different mode of IoT you can start building over there, you can start working over there. So that is just beginning. There is no limit that you can just get limited in IoT only this part, because IoT is just a beginning, and in any extent you can go with that IoT. You can build any kind of advanced product using IoT. So that is up to your requirement, up to industrial requirement. So main important parameter is that when we are going to design any IoT solution, that should be reliable, that should be scalable, and that should be cost effective if you want to sell it in the India. So these three things is very important when we are going to develop any kind of IoT product. So that can be done over there. So now we are moving ahead over here. So these are few tools that I have discussed over there. Further also there are many more platforms that can be used for IoT application, like you can use Windows, also Microsoft also you can use it, IBM platform also you can use it for that tools, and you can use that Amazon also, Amazon Cloud Source also you can use it over there. So there are different mode of cloud that you can use it. Those are paid versions that can be used over there. So now I'm just sharing with you my contact detail also, because if any participant face any difficulty while understanding it, so they can contact me anytime. So these are my contact details, and we are going to launch one advanced IoT course also for 2-week and 1-week mode. So for that you can feel free to contact me anytime. These are my contact numbers, mail ID, and we are available on the Facebook, Instagram, and Twitter with the Innovate Skill and Ajay Godara. You will find me over there. So further also, if any participant having any kind of doubt, any kind of queries, I will be happy to answer your queries. So you can type over there in the chat box. Yes, if any participant having any kind of doubt, any kind of queries, they can type over here in the chat box.
So they can unmute and ask the questions as well. Participants are requested to ask your queries if you are having any query.
Good evening, Ajay.
Yes, if any participant having any kind of doubt, they can type in the chat box, or they can unmute their mic if they are able to do it.
Yes,
And
sir.
I will be
This
happy
is
to answer
Sandip
your
Kumar,
queries.
Dr.
And if you
Sandip
want
Kumar
to
from
ask
Pune.
later on, like if you're working any projects and you are facing any difficulty while building any product, or if your student facing difficulty, so I shared with you my contact detail. You can WhatsApp me anytime. So I will be happy to answer your queries.
Sir, there is one participant who wants to ask a
Sir,
question.
Ajay sir, good afternoon, sir. This is Sandip Kumar from Panimal Engineering College, Chennai. It is audible to you, sir?
Yes, sir, audible. You can ask.
Yes, sir. Actually,
Madam,
once
if any participant having any queries, so kindly let me know. I will be happy to answer their queries.
sir, there is one small question, sir.
Yes, please.
Sir, you said all the data are stored into the cloud. Actually, IoT, any real-time cloud database is available for storing free of data and also for analyzing, sir.
Yes, as I shared with you, one that cloud that is Sane Cloud that is also open source. So over there you can store data. So right now I have not shared with you data type. So over there is we are going to click on the data. All the data is being get stored, and you
Very
can
good, sir.
download it also. That is freely. That is one.
Okay.
Second one
Thank
is that if you are going to do some analytics, so analytics, if you are going to use it using MATLAB, so there is one cloud of MATLAB that is ThingSpeak. That also you can use it, and that you can integrate it with the MATLAB also. So ThingSpeak. So that is limited free. So limited data you can store it over there, and that is freely you can store it.
Thank you so much, sir.
Yes. So over there, data can be analyzed also. So if you want to do any kind of analytics with that data, any kind of algorithm of MATLAB you want to deploy with that data, that also you can do it using ThingSpeak.
So there are few queries in the chat box as well.
Okay, madam, I'm just going to check it out. Yes, when we talk about Tinkercad, over there only you can do circuit simulation and sensor simulations. So when we talk about real-time data set over there, so in the Tinkercad we cannot do it, but whatever project we are going to build it on the Tinkercad, same project we can deploy it on the hardware also. From the hardware we can acquire the database, and that data we can upload it on the cloud also. But on the Tinkercad, we can use only circuit simulations, sensor simulations, and the microcontroller coding that you can do it. You cannot connect it with the cloud. You cannot send data to the cloud over there from the Tinkercad. Yes, when we talk about LoRa based simulation, that also can be done. So for that, there are some software that can be used for LoRa simulations. So when we are going to use LoRa based network, so for that, for the simulation, there is one software that is Cup Carbon. So Cup Carbon software can be used for LoRa simulation. Let me share with you over here that software also, so that you can get familiar about it. So Cup Carbon. Cup Carbon is a software that can be used for LoRa simulations. So that is also open source. So Cup Carbon IoT simulator. So that is being used for a LoRaWAN application. Like if you're going to build smart city projects, so over there you can use that Cup Carbon tools like this. You can see the animation over there. So that is latest version, that is 5.0. So wireless sensor network simulator, you can use it for
an IoT and wireless sensor network simulator. It can be used to design and program distributed systems in general.
So that can be used for that applications. Yes, that I have answered. If any queries I am not taken it over here, you can type it again in the chat box. So I will be happy to answer your queries.
Hello, sir.
Good evening, sir.
Yes, please.
I just want to ask you, what is your perception about the trust level of security standards on IoT?
Trust level in terms of a security. So right now, when we talk about the platform that is being used in IoT, the MQTT protocol is being used over there, and that is till now that is one of the secure platform over there. All the data is being encrypted, so that that is known as secure till now. So all the maximum top companies those are using that, those companies are using MQTT protocol. So we cannot say it is 100% secure, because once something is coming on the internet, we cannot assure that it's fully 100% secure. But that is till now, that is secure platform that is being used, that is MQTT protocol.
Okay, sir. Thank you very much.
Hello.
Yes, please.
Sir, good evening. I'm Sonam.
Very good evening.
Sir, I just want to ask that can we use this carbon IoT tool in implementing SDN networks?
SDN stand for?
Software defined networks.
So software defined network, we cannot use it. That is being used for practical application. Like if you are going to deploy directly on the hardware. So for that you can simulate it. Just take an example of you are going to build smart city project in a real time.
So like if we want to implement the virtualization technique,
yes,
so can it be done?
So that can be implemented.
Yeah. Okay. Means virtualization we can do it in.
Yes.
Okay. Thank you, sir.
Thank you. So when we talk about the different simulator related to IoT, so we cannot list out over here that with this one we can use it. That depend upon application based. So what kind of application you are going to build it for the IoT, like as I discussed over here, like if you are going to build for smart city and you are going to use LoRaWAN, Wi-Fi or ZigBee protocol. So for that you can go with the cup carbon also. When we are going to work with only the automation project, or we want to start with the data acquiring from the sensors, so for that you can use Tinkercad. And when we are going to talk about Raspberry Pi uses, then you can go with any further many tools are available that can be used. So further also, if any participant face any kind of difficulty, I have shared with you my contact number also. So feel free to contact me, no need to worry about it. So few simulator that I shared with you, those are real time. If you want to know more detail about more simulator, you can WhatsApp me and I will let you know based on your application that what you are going to build it. So whatever shared with you, all are free cloud, free open source tools that can be used. And further also, if you want to know more, you can WhatsApp me anytime.
Any queries, any other queries from the participant side? Sir, I think it's over from the participant side. And yes, sir, we will provide you the recordings at the completion of the FDP. And I have shared with you the attendance link of afternoon session as well as for the morning session. And at 4:30, I will close the link. So please fill your forms for the attendance purpose. Sir has shared his email ID as well as mobile number for further discussions with the participants. Sir, your session is very informative, and the way you have presented is very attractive, and the animations are very interesting. So thank you, Ajay sir, for sparing your time and do the adjustment for a very short notification. Thank you so much, sir.
Thank you, madam. Thank you so much. My pleasure.
Now I request all, sir, I request all the participants kindly switch on your cameras so that we can have the photograph with the our speaker. Yes, thank you so much. Kindly. Sonam Sharma, kindly switch on your camera. Yes, thank you so much. Just wait for a few minutes. I'm saying again and again to for the photographs because we need these photographs to upload on the ATAL portal. So that's why I'm requesting you again and again to switch on your cameras for group photograph. Yes, thank you. Many of the participants have not switched on their cameras. I hope you all enjoyed today's session. And tomorrow again we are having very informative sessions, and we will assemble at 9:30 sharp 9:30. We will follow all the time schedules 9:30 to 11:30 morning first session, then 11:30 to 1:30 second session, and we are having 1 hour lunch break, and 2:30 we are having third session. So see you all tomorrow. Thank you so much. Now you people can leave.
Thank you, ma'am.
Thank you so much.
Thank you, ma'am. Thank you.